Hello. Hello and welcome. Thank you so much for joining us. My name is Aisha Blake, and I am the Director of Developer Relations for Pluralsight. I am really excited. This is my first Tech Skills Day as a member of the Pluralsight team. This is our 4th annual Tech Skills Day. So I'm really, really excited to lead us all into the event. So Tech Skills Day is really a celebration of our community. We're going to start off with 2 absolutely wonderful keynote sessions, which will then lead into technical talks, career discussions, Q&A, and an opportunity to really connect with all of the other attendees and start to have some conversations based on what you've learned and what you've heard throughout the day. So we've got a couple of keynotes for you to start off the day. I'm going to guide you through kind of that section of the day. We're going to start off with an absolutely wonderful session from Scott Hanselman on mentorship, sponsorship, and storytelling. And then we're going to move into how to build projects that get you hired by Forrest, Brazeal. We'll split into 2 tracks after that, cloud skills and developer skills. And we'll absolutely have breaks for each session, so you don't have to sit through the whole day. We'll break it up so that you're able to kind of take everything in. So on our ACG Cloud Skills track, you'll hear talks like Cybersecurity is for Everyone from Geeta Sharma, and a closer look at building data collection solutions in the cloud with Banjo Bayomi. In the Pluralsight Skills track, you're going to hear talks from our very own David Neal on JavaScript, past, present, and future, as well as a dive into building your first Terraform module with Ned Bellavance. After all of that, at the end of the day, you're going to have a chance to meet and chat with other developers via our Gather platform. In addition to all of that, we've got a little bit of an activity for you. So if you're paying attention throughout all of these different sessions, you're going to see some sunglass stickers popping up all over the place. So we're running a sunglasses Easter egg hunt. We've got those stickers hidden throughout the event, so keep an eye out and tally them up when you spot them. At the end, you're going to be invited to submit your guess as to how many of those sunglasses stickers you found throughout the day, how many you think there have been throughout the day, and the first 5 closest guesses without going over, so Price is Right rules, are going to win some really cool swag, including a Loom Cube panel, a Lark self-cleaning bottle, and an Oculus Quest 2. I'll help you out. I'll give you a little bit of a hint. The first one was in the agenda slide, and this one counts too. All right. So I am going to go ahead and introduce our first keynote speaker. I am so excited to share this talk with you. What I love about both of our keynote sessions today is they're super actionable. You're going to hopefully be inspired and energized by them, but also you're going to walk away with some really actionable steps that you can take to take your tech career to the next level. So with that, I'm going to start off by introducing Scott Hanselman. Scott is a former professor, a former chief architect in finance. He's now a speaker, a consultant, a father, and a Microsoft employee. He is a failed stand-up comic, a corn rower, and a book author. And that's him today. He'll be different tomorrow. I really appreciate the kindness and the joy that Scott brings to not just his talks, but the way that he teaches tech. It's something that really inspires me as an educator, and it's so meaningful to me that he was able to put this talk together for us and share it with us. And so I know we're running a little bit ahead of schedule, but I'd love to lead you into mentorship, sponsorship, and storytelling by Scott Hanselman.
Hey friends, I'm Scott Hanselman. Welcome to Pluralsight Tech Skills Day. I'm very excited to be chatting with you today. I've got an interesting talk that I enjoy doing called Mentorship, Sponsorship, and Storytelling. And when I submitted this talk, the folks at Pluralsight were excited about it, but I was already told that my slides were unprofessional because apparently you're not supposed to use Comic Sans in your slides. So I immediately went and tried to fix that, and I brought in some like professional font people, and this is what I came up with. But then Aisha from Pluralsight was like, you need like some evocative stock photography, maybe something that shows what a tech person's desk looks like. So of course I took a picture of my perfect desk with the sunlight streaming in on a Sunday morning. I know that we all have desks that look like this, right? Real computer people have desks like this. But no, this is kind of what a typical computer person's desk looks like. But then I realized, as I was making that joke, and I say, well, a real computer person's desk looks like this, or a real computer person's desk looks like that, is that I'm starting to evoke already without meaning to a sense of gatekeeping. Because what if you're saying, well, my desk doesn't look that neat, or my desk doesn't look that unorganized? What does a real computer person's desk look like? Well, it looks like whatever the heck you want it to look like. And that is so important. I want you to feel welcome. The friends at Pluralsight want you to feel welcome. And we don't want you to feel like a computer person looks like anything or anyone. Now, when you go out there on the internet, you're going to find a ton of folks that are going to tell you how things need to be done. And they're going to say, well, you're in the middle of a pandemic, and if you didn't learn Pascal, Chinese, and JavaScript during the pandemic, then what were you doing with all that spare time? That's hustle culture. And you don't want to get too into hustle culture, because if you're not hustling, then you feel bad, right? And people tell you that you have to behave a certain way. And I have to ask them, is hustle culture healthy? Yes, it's good to hustle. Yes, it's good to work hard. Is it good to work 100 hours a week? Is it worth watching and binging on every Pluralsight course? Maybe not. Maybe you want to think about how you're moving through the world. You cannot just wake up, kick butt, and repeat. You have to take a little self-care, and that's super important. Now, as a remote worker, I've worked remotely for Microsoft now for almost 15 years. When the quarantine happened, everyone gave me a call and said, hey, Scott, tell us all about what it's like to work remotely. And I had to remind them that remote work and quarantine work are not the same thing. It's a very, very different situation. Remote work is a joy. We can stay home. I can go to McDonald's. I can go to Starbucks. I can work from my laptop. It's a very glamorous thing. But being trapped in your house is not super glamorous. And unfortunately, in the time that the quarantine's been going down, we're all feeling a pressure to overwork. We're finding ourselves with less commutes and thereby more time to delete email and watch Pluralsight courses and do stuff like that. And that pressure to overwork can be incredibly stressful. I've also been finding myself doing a bit of doom scrolling, which is, I'm not sure what I'm scrolling for, but I'm looking for doom because everything's bad and the world is ending. And if I don't get my act together quickly, I'm going to be fired at work. This is super important for us to talk about as a community because there's a feeling that your neighbor, that your friend, that your coworker is doing better than you in some way. And we don't have those conversations in public. And I know that our friends in Pluralsight want us to be our full and complete selves and talk about what we know, what we don't know, to be deliberate, to be intentional, and to really be present in the moment. So what I've started to do as I improve my learning, as I improve myself at work and personally, is I've started to be focused on deliberate practice, be as awake as I can be. And I've started by making a nest. I made a nest at home. I think you should make a nest as well. You take a look at my background right here, and this is what I call the $1 million room that cost me $300. It's a cool background, and you go, oh my goodness, I wish I had a fancy office like that. But ultimately, these are IKEA Billy shelves. This is a $50 LED light. This is an arcade that I got at a bar, painted black, and put an Xbox inside. So you too can have a $1 million room for about $300 and a can of paint. The point being, your room, your space is a nest. And just like birds make nests for their family, you need to make a nest for yourself so that you can be your best at work, your best in learning. And then when you have that space, you can ask yourself, instead of thinking about hustle culture, you say, is now the time to create? Is now the time to learn? Am I going to start talking about my learning journey and maybe blogging about it? Well, I shouldn't blog, right? Because I'm not an expert yet. I'm still learning, right? I'm learning every day. But everyone is an expert at something. So maybe you should be thinking about what you can blog about, perhaps your journey, perhaps the time that you're spending learning new technologies and interacting with the community. There's an opportunity here for all of us to share our experiences. Now, some of this might not seem like the attitude and the style that you're used to. A lot of people enter tech and they don't feel welcome, they don't feel warm. So we should talk a little bit about attitude and style, because not just I setting the tone here today in this short keynote, but others that you may interact with online or on Stack Overflow may be welcome and may be kind, and other ones might make you feel kind of lousy. We all hope that tech welcomes you warmly. This is one of my favorite magazine covers from March of 1984. 1984, my friends. The young lady here is coding. She's got her pigtails. She's got her mouse and her TI-99 computer, and she's coding away. And that's what programmers looked like in March of 1984. But sometimes if you watch shows like on Nickelodeon, you see these what I call Power Rangers diversity, where you basically get one of each flavor, and it's always the same 5 kids, no matter what the show is. And that you see these quotes. And one of the quotes that I always hear is diversity is being invited to the party, and inclusion is being asked to dance. I'm like, that's a good quote, but let's be real, right? Inclusion is being a member of the party planning committee, right? It's not about being asked to the table. This is about actually building the table from scratch. And this brings me to the very definition of that word inclusion. Inclusion is the opposite of exclusion. That's all it is. So are we doing a thing that's excluding people and making them feel bad? Well, there was a time when we had this technology priesthood. No disrespect to our priests, but a couple of thousand years ago, there were the people who can read, people who had access to information, and then there were people who couldn't. And the people who couldn't read were stuck. They could only get their information from the people who chose to give it to them. And Ted Nelson here said that knowledge is power, so it tends to be hoarded, and experts rarely want people to understand what they do. Not our friends at Pluralsight, of course, because the information is available and it is here. This seems like a quote that could have been from 2020 or 2022. In fact, this is a quote from 1974. They were already watching out for technology gatekeeping. What's gatekeeping? It's just literally standing in front of the gate and saying you can't come in. It's just the people that control that information flow for a system. And that's why having access to training materials for learning, open source, blogs, Twitter, Stack Overflow is so important. That kind of information is available to you now on the internet. Never before has everything been so available for learning than today in 2022. We're seeing more and more folks that are moving up in tech, getting promoted, getting that first job because they have access to information. So we should put our information out there in the world. We should share our energy. We should share our energy and put out good work. That's what I personally have been trying to do. I've had a blog for 20 years. I've had a podcast for 16 years. I've been on the internet since its inception, at least for 30 years ago. And in the goal of being on the internet, what I've been trying to do is put out good work and avoid wasting my keystrokes. My keystrokes, what does that mean? Well, let's say that someone in the audience decides to send me a note. Let's say that Aisha says, "Hey, Scott, great talk. Good stuff." And we're like social friends, like we know each other on Twitter, but like I don't really know her like that much, So she's like, "Hey, Scott, here's a question." And the question is a gift. What a great question. I never thought about that question. I need to answer that question. I'm like, yeah, but I don't really know. I don't know her like that. Am I going to give her the gift of 3,000 of my keystrokes? That's going to take me like a half an hour. And then she's going to say, "Thanks." And then those keystrokes are gone. Those keystrokes are dead. I need to conserve my keystrokes. Right? There's a finite number of keystrokes left in my hands before I die. So where should I put them? I'm never going to get more keystrokes back. I've actually gone, because I'm just that kind of a nerd, and I actually wrote a website called keysleft.com, where I can put in how old you are and how fast you type, and I will actually tell you exactly how many keystrokes you have left, and the number will go down as you sit on the website. This is assuming that you type 4 hours a day until you live to be 90, and it tells you exactly how many novels, how many computer programs, or emails to your boss you have left in your hands. So back to the original question. I get a great question from the audience. I don't know where I'm going to put that. I'm not going to give away that. I'm not trying to get it for the money. Maybe I should put it anywhere with a URL. Anywhere with a URL. Twitter, a blog, LinkedIn, Facebook. Maybe I'll make a Pluralsight course. And then I'll send a link to the course and I'll say, "What a great question. I made a course for you." That's sharing your information in an efficient way. I've been spending all of this time on the internet trying to not email people. Because when you email people, you just get back more email. So if someone asks you a question, make a SharePoint document, make a Word doc, put it in Google Docs, put it anywhere with a URL and start sharing information. And not sharing it in the way of, "I'm an expert," because we're all amateurs. We're all amateurs. There are no professionals. Everything that I learned in school is gone. Every programming language that I ever learned is dead. Everything that I do today didn't exist when I started in computing. So then I have to be really honest with myself and say, do I have 20 years of experience? Or do I maybe have the same year 20 times? And this is a really interesting one because you'll come in contact with people, sometimes like me, and they'll say, "Well, I've got 30 years experience in the field." What does that really mean? What does that really mean? Well, that means that I haven't been chased out of tech. It means that I'm still here. It means that I've got resilience and I'm somewhat lucky and somewhat persnickety. that I'm not going to quit. But to be totally honest with you, in the last 30 years of being in tech and coding for money, I'm going to say maybe 7 years of it, I was asleep. And I mean asleep in that, like, I was just kind of, making some code, and I wasn't really learning anything. I wasn't thinking about new ways to interact with people. That's okay. That happens to the best of us. It doesn't mean you have to go back and do hustle culture. It doesn't mean you have to learn a new language every year, but it means that you need to wake up a couple of times a week and go, oh, what did I learn today? Did I learn anything new? Did I think about something new today? And then you try to wake up multiple times a week. Have you ever been driving and then you're like, you go 4 blocks and you're like, whoa, I'm driving. Just a moment. I'm not saying you fell asleep. You just weren't present while driving. That's what I'm talking about by waking up and saying, wow, have I been interacting with my coworkers correctly? Have I been using C# in the way that I think it's supposed to be used? I haven't even looked at Kubernetes in a while. Maybe I'm not an expert. This is really healthy introspection. And one of the people that I like to think about when I think about senior engineers is I think about Tim Berners-Lee. Tim Berners-Lee invented the web. But when he gives a presentation, look at his title. He didn't say senior web developer. He didn't even say the. What if he said the web developer? What would you do if you met someone at a party and they said, oh, what do you do? I'm a web developer. Oh, you're a web developer? No, I'm the web developer, right? That's a very healthy and mature attitude. I'm very sure that he does not know everything about the internet, just the part that he invented, but the internet has grown, right? So I think he knows that it's probably, you're never too old to get good advice. Maybe he has some mentors that are younger than him. So as I go out there and I try to learn more and I try to be more present in the community, I have mentees and I have mentors. I am not too old to get good advice, and neither are you, no matter what age you are. And you're never too young to share experiences. A lot of times, the mentor-mentee relationship can be somewhat stilted, and it becomes a weekly lecture from an old person. And I'm guilty of mentoring some people where I was doing a big dad energy weekly lecture from an old person. And in fact, that was not what that person needed, and that's not healthy. Mentors are supposed to be mirrors. They help you define your dream, help you with your strengths. They help you with advice. They don't lecture you. But the other thing that's important is there's a big difference between mentorship and sponsorship. Sponsorship is more important than mentorship right now. A lot of people, particularly underrepresented minorities, are over-mentored. If you want free advice from an old person, you can get that anywhere. But sponsorship means I've brought you into a room and I've stepped back and I've said, hey, you should talk to Tom. He's got some great ideas. Oh, I think that was actually Anna's project. Let me have Anna explain that to you. Sponsorship is really powerful because I, as a person who's been in tech for 30 years, have an unlimited amount of this level of privilege where I can just go, oh, you should talk to so-and-so. I can be all kinds of sponsors. What's cool about this and what's powerful about this is I could be a mentor. I could be a strategizer. But I can also be a connector. Oh, you should talk to Aisha. Oh, you should talk to Jeremy. They know about that. And then I just do a little connector. You can be an opportunity giver. Have you heard about the new Pluralsight? Let me hook you up with a free subscription. Maybe you should speak at their next event. I can advocate. Oh, you should definitely have Saran speak at that event because she's great. Oh, yeah, I've seen her talk before. Costs me nothing to do that. So sponsorship is just as important as mentorship. So if you either are a mentee or you are currently mentoring, think about a way that you can turn that relationship into something that creates luck for people. Now, saying that things are lucky and saying that my life and my career has been shaped by luck does not in any way indicate I didn't work hard. It rather indicates that I had opportunity plus being prepared, and they combined into luck. How many times have you bumped into someone on the subway or the bus and then you find out that maybe they work somewhere and they give you a business card and then your entire life changes and you move across the country? That happens all the time. But there's a ton of people out there who are prepared. They've watched the courses, they've done the certifications, and they're ready to go, but they're just waiting for that opportunity to meet their preparedness. So I can be the luck. I actually made a hashtag be the luck on Twitter. It could be that you give someone a laptop. It could be that you invite them to interview somewhere, that you take a look at their resume and you hand it to a friend with the warm introduction. The warm intro is super important. Those kind of things are all the kinds of things that people who are preparing, whether it be on Pluralsight or other places, they're prepared. They just need an opportunity. And I, as an elder millennial, have an unlimited amount of the ability to go and do those kind of sponsorships. I can go and lend my privilege to them, thereby giving them opportunities. Whether they're prepared or not, in that case, will be on them. So very, very important to remember. Now, when we start a mentorship relationship, you have to remember also it's not forever. You don't have to go out with them forever. You can break up with your mentor or your mentee. The best way to do that is to just time box it. Why are we doing this right now? Are we trying to learn C# or are we trying to get you promoted? Let's figure out what our goal is and make it a sprint. So kind of applying Scrum to mentorship. And then, of course, remembering, as I said before, that it's a two-way street and not a scheduled regular lecture. Now, as I get towards the end of my talk here, I actually have a bunch of fun stories because I think one of the great things about being a person who's been in tech for a long time are the stories. And the great thing about the stories is I've collected them and I want you to collect them as well. People who have been in tech for a long time are filled with wonderful stories. And the first thing I'm going to start with is a reminder that Swiss Army knives are actually super useful. My dad gave me a Swiss Army knife when I was 12, and he said it's not a very good tool for anything, but it's got a lot of tools on it. And I realized that I'm kind of a tool myself, and I've got a bunch of different things that I'm not very good at. You know, I'm a pretty good knife, but everything else, I'm a lousy pair of scissors. This is what's called the T-shaped developer. Imagine the shape of a T. You're very broad, somewhat not very deep, but you understand fundamentals, and then you go deep, like the top part of the bottom part of the T there. So you say, I'm going to go wide. I understand computer science. I understand CPUs. I understand algorithms. And I'm going to go deep on Kubernetes, or deep on Python, or deep on C#. But I'm focusing on not being a lousy knife. You got to be a good knife. You can't skimp on the basics. So a lot of my stories relate to those fundamental computer science concepts that aren't technology specific. Usually they break down in terms of problem solving, layering, composition, and patterns. So I'll tell you a couple of these. Problem solving is a great one. What's the difference between an early career engineer and a late in career engineer? It's literally the ability to ask yes/no questions at scale. That's all it is. So I was giving a presentation at Black Girls Code, and I was talking to a bunch of 14-year-old kids. I think they're maybe either freshmen or eighth graders, and they're all excited to hear from this random old person who's going to talk to them about Microsoft. And hey, let's learn how to program, everybody. And I showed up and I said, all right, kids, my toaster's broken. And I just made it super cringe, very awkward. Just sat there with the kids and go, hey, my toaster's broken. What am I going to do about it? I thought we were going to program. Yeah, but I need my toast. So people start making guesses. They start making kind of simple guesses. Well, you should probably buy a new toaster. Valid. Maybe not the best debugging solution, right? Buy a new toaster. But I said, let's try to think a little bit outside the box. Like, this toaster isn't alone in the world. It exists in a system. Let's try to apply not simple thinking, but rather systems thinking. And I paused, made it super awkward. And then one of the young ladies says, well, is the power on? And I said, here you go. The power is not on. How am I going to fix that? And they said, well, could you plug in something else, like a lamp, and see if the lamp turns on? And I said, that's a great idea. And they start thinking outside the box. Well, what about the fuse? There's a fuse thing in the garage, right? Okay, now we're thinking about the system that the toaster exists in. And then they start talking to each other. Well, hang on, is the power on at all? And then this is where the breakthrough happened. And this is where you have a programmer. You've got a programmer who came built in as a kid as a programmer. Young lady says, do the neighbors have power? Think about that for a second. I asked about toast. I said, I want some toast. And she says, I'm looking out the window and I want to know if the neighbor's lights are on. That's a system thinker. That's a person who's trying to understand how everything works. Because for some folks, the wire comes into the house and a miracle happens and toast appears. But for others, they know that there's maybe a hydroelectric power plant and the river's rushing through it and it's generating power and it moves through wires all the way into your miracle toast. And then, of course, at this point, because they're young kids, it all falls apart, and they're asking about maybe there was an EMP or aliens have taken over and the power is out for the entire neighborhood. But the point was still made, which is important. So for your early in career folks, they Google a lot for stuff. Sometimes they Google with Bing. And the later folks, they'll just eliminate an entire class of problems. They'll eliminate an entire class of problems just by asking the right question. So as an experiment, I went and I wrote down a bunch of questions that might help one debug a web application. Just made them up, just literally picked them. And I just wrote a whole list here. IP addresses, SSL certificates, environment variables. These are all guesses about what could be wrong. And I realized that I could probably do this for pages, 500 or 600 questions. Did you check this? Did you look at the logs? Did you look at the branch? All these different things. Or as our great American president, Abraham Lincoln said once, it's always DNS. It's always DNS. These are the kind of questions that, how did I collect that list? The way I collected that list is by being in tech for a long time. You can't learn this stuff. You have to live this stuff. But in order to live it, you have to stick in tech, and you have to be given the opportunity to fail in a comfortable way with a team that allows you to screw up and not take down production, but still make these mistakes. Everybody's got a story about one of these things. So it's the applying of your training, of your courses, of your certifications to something in reality. We don't expect you to know this list. We expect you to think about, well, is it the fuse? I don't know. It might be this. It might be that. Those are the kind of questions. Now, my kids insisted that I add this one here. It's never twins. Sherlock Holmes. This is actually a debugging thing. Sherlock Holmes is trying to find a murderer. This young bride has killed her husband, but then she was also seen on the other side of town. And Watson says, well, it must be twins. That's how she has an alibi. Could it have been twins? No, it's never twins. There's certain things that it's just never that thing. And you can only learn those things by being in tech for a long time. We'll touch on layering a little bit as we get towards the end here. Hiding complexity in software is layering things on top of each other. And layering is actually a lie. Layering is just lying. A really good abstraction layer lies really, really well. For example, here's what an email looks like. We've all sent email. We've all attached a file. We don't really think about it. But if you flip that over, imagine just flipping it over and looking at the text underneath it. You see that we have from : name. To : name. It's name value pairs. Name : value. Then we've got this multi-part thing here in pink, but it's basically looks like a hash table. Name value, name value. So let's look at an HTML form. Isn't that interesting? Name value, name value. Did you know that an HTML form and an email are using the same underlying technologies? Most of the stuff that is new and interesting that you think is new and exciting are the same Lego pieces snapped together in a different way. You know this stuff already. A lot of great stuff happening in the Lego space right now, but ultimately the stuff they're building are using the same elements that they made 50 years ago. New ideas are just reused old ideas. On the right here, we have a Victrola, a record player, with audio encoded in a circle with a head. The data is in a circle and it spins. On the left, we have a hard drive with data encoded in a circle and it spins. These are 150 years separated from each other, and the same idea is fundamentally there. When we start taking these things and plugging them together, we can compose them in really interesting ways. Here's my last story. I got a buddy of mine who's on a show called Altered Carbon. Altered Carbon is this show, and in the case of my friend Chris, he plays an AI, and the artificial intelligence is a hotel concierge. So he is the hotel, and the hotel is him. So he lives in the hotel, he is the hotel. And he just chews up the scenery. He's amazing. He's just unreal. And so I tweeted the guy because I always like supporting kind of that supporting actor, because the famous people aren't going to answer you, but the mid-level people are be like, hey, you did a great job on Altered Carbon. And he's like, yeah, thanks. And I noticed he was in Portland. So I said, I'm in Portland. I said, let's have tacos. So we go and we hang out. He shows up in a vest with an ascot. That's the level of cool I can only aspire to. I'm here cheesing, and this guy comes in with a freaking ascot. It looks like $1 million. And we do a podcast, and he's just a sweetheart of a guy. And I'm loving this. And I'm like, oh, this is good. I've got this burgeoning romance with this cool person. I'm telling my wife, I'm going to go hang out with the guy from Alter Carbon. And we do a podcast, and it's amazing. And I have my portable recorder, and it's so fun. And then I go home with the little SD card, and I plug the SD card into my machine. And there's nothing. There is a recursive, empty folder with another folder inside it, with another folder, with another folder, another folder. And I felt physically ill. I felt it in my chest. I'm like, do I call this famous actor now and tell him that we need to do it again? Hey, you remember that lightning in a bottle that we caught? Can we catch that again? That would be ever so great. I thought I was going to die. Do I just ghost him? Right? I'm working on a bromance here. Like, I thought I got a new friend. This is going to be great. So I'm like, the only solution is to go and dig deeper into the layers. So I take a look at the files on the SD card, and I notice that there's 300 megs of used space. Well, that's interesting. That's not the same as a bunch of empty files. So I start learning. I'm not a low-level programmer. I don't know about file allocation tables, but I know that there's documentation, and I can start digging around. So I take a dump of all of the bytes on the disk. You know, when you make like an array, when you're learning computer science, you have an array of numbers. All an SD card is an array of numbers that's really long. So I ended up with a 300 megabyte image file of the SD card because I didn't want to break the SD card. And I start looking at it and reading the docs and trying to understand what's going on and learning about hex. And after about 17 hours of reading and learning and reading and learning, I pull the files out and I discover the files. I don't know any. I'm a web developer. I live here. I live up here because these layers work. I don't worry about these layers, but those layers exist and I know they exist. So I can just dig deeper. Some of you might be .NET programmers or ASP.NET programmers. You might be a Django programmer. I don't know where you operate, but whatever you're sitting on top of, the stuff underneath is not hidden from you. You do not have to worry about that. You can just dig deeper. Nothing in the computer is hidden from you. And then once you see those things, now you're becoming an elder programmer. You say, hey, I've seen that before. That's all it is. I've seen that before. One last story. Then I got to go. Okay. I had this file I was trying to compile for a Raspberry Pi, which is a little tiny device, and I copied the file onto the Raspberry Pi, and it wouldn't work. And it kept crashing. And it worked on my machine, but it didn't work in the Raspberry Pi. So I took the two files and I put them next to each other. And I said, here's the good file and here's the bad file. And I noticed over here on the good, I had these 0 Ds. But if I looked at the bad file, there was just an empty space where 0 D should be. How would I solve something like that? What's going on? You can't Google your way out of a problem like this. I start digging around and I discover that the FTP program that I'm using has a setting that says it'll treat a file without extensions as ASCII, as text. So why does that matter? Why does that matter? Well, it matters because 0D means carriage return. So I figured the problem out. I was transferring this file as text, and I went and I told one of the young people in my at my company about it, and they said, interesting, carriage return, huh? What's a carriage and where is it returning? I said, oh my goodness. And I ran over here to get my Lego typewriter. And I said, well, it's 2022. And, you know, when you commit things to Git, you have to think about carriage returns and line feeds and stuff. Here's a carriage. The carriage carries the paper and the line feed feeds the line. So when you are typing on your Lego typewriter and it moves the carriage at the end of the line, it goes ding, and it comes all the way back. And that's a carriage return. So that's the code for a carriage return. But I don't use typewriters. I've never seen a typewriter. Yeah, but a typewriter affected why that code exists, and now it's in Git, and now it's on Windows, and it's different between Windows and Linux and Windows and Mac, and this is a thing. And how would you know? You couldn't know. You'd have to see it. But now you know. And the next time, watch this. You know how when you learn a new word and then you've never heard this word, you lived 30 years on this planet, you've never learned this word, then you hear it 3 times in a week? You're going to see a 13 or a 10 or a 0D or a 0A at work tomorrow, or you're going to think about carriage return line feeds changing in Git, and you're going to go, well, did you know that the typewriter, blah, 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 blah. And then you're going to sound like an elder programmer, and you're going to share those stories with the young people at your company. All of this is just to tell you that I am very, very glad that you're here, that you're joining us today, whether you've joined Pluralsight and the friends here at Tech Days to learn more or to sharpen the saw, whether you're early in career and you're just getting started, or whether you're just trying to get that big promotion. We appreciate that you're here, and I thank you very much for hanging out, and I'll turn it over to our hosts for the rest of the day.
All right, that was awesome. That story about the podcast recording had my heart racing. It's still racing, if I'm being honest. What I really loved about that talk is the emphasis on problem solving through practice. And what I mean by that is this idea that, what might seem like genius to you when you are new, when you are just starting to learn, it's attainable, It's attainable because you, over time, over trying things, trying to build, you can absolutely build that muscle. You can start to recognize those patterns. And over time, you start to get faster and faster and figure out those questions to ask. Love that. Love it. So we're back. We are going to move straight into our second keynote of the day. Very excited to share this one with you as well. So next up, we are going to hear from Forrest Brazeal. He's a cloud educator, an author, and Pony Award-winning songwriter who is currently Google Cloud's head of content. He is often called the Tom Lehrer of the cloud. He specializes in using music, humor, and creative illustrations to make technical topics memorable and engaging. So Forrest was previously an AWS serverless hero and is the creator of Cloud Resume Challenge, which has helped thousands of career changers and upskillers take their first steps into the cloud. We're going to talk a little bit more about that, a lot more about that in this next talk, Beyond the Cert, how to build projects that get you hired in cloud. Again, one of the things that I'm really excited about here is this is so actionable. You're going to get some steps that you can take, that you can start taking now to move forward in your career, especially if you're looking to get into cloud. And so I encourage you to really keep these tips in mind, keep these steps in mind, and absolutely check out the Cloud Resume Challenge. But keep that in mind even today as you're listening through the talks, especially if you're choosing to go through the cloud track. So this next talk, how to build projects that get you hired in cloud. We're going to talk through how to, like I said, get beyond the cert. It is going to be packed with real stories, real world lessons, shared from the Cloud Resume Challenge community. And that will help you hopefully close the gap between getting your first certification and getting your first job. So whatever your background, you'll be able to bring really valuable skills to the table and leave this talk inspired to really take those skills to the next level. So with that, I'm going to lead you into Beyond the Cert, How to Build Projects That Get You Hired in Cloud by Forrest Brazeal.
Well, good morning, good afternoon, good evening, wherever you are. It's wonderful to be here with you today. My name is Forrest Brazeal, and I'll tell you a little more about myself in a minute. But first, I want to introduce you to someone much more interesting. His name is Daniel Singletary. I met Daniel a couple of years ago, kind of right in the beginning parts of the pandemic. Daniel at that time was a residential and commercial plumber working in Metro Atlanta. And his job was about what you think a plumber's job is. It was long days, he was on his feet a lot, and he dealt with the kinds of things you might imagine a plumber deals with. He also dealt with some things you might not imagine that a plumber deals with. I'll give you an example. One day, around the time I met him, Daniel was called out to a shopping mall, a suburban shopping strip near Atlanta, because the owners had reported a mysterious and really noxious smell flowing through the building. All right, maybe something that a plumber might be expected to deal with. So Daniel shows up, he starts looking through the building, he can definitely identify the smell, follows into the bathrooms, eventually takes one of the toilets off the floor, and that's where he gets hit with a blast of stinking air. He described it to me as, imagine a leaf blower blowing sewer gas in your face. Now, I'm not a plumber, but Daniel assures me that not only is this not something that should happen, it shouldn't even be possible. You shouldn't have moving air flowing through a sewer duct like that. So, begs the question, what's going on? Daniel comes back to the shopping mall with a colleague, and they start systematically working at opposite ends, trying every fixture, see if this is where the air is escaping, and they can't find anything. Remember, this is an active shopping mall. You can't just, shut down all the plumbing while you figure out what's going on. So they've got to take it fixture by fixture. Eventually they meet in the middle, and they've narrowed the problem down to either a nail salon or a restaurant. One of these two places is what's causing the problem, and that's where they stopped. At this point, only thing left to do is what we call a smoke test. Now, if you've been in software, you may have heard the concept of smoke testing, but this is a literal smoke test. They took a smoke bomb up onto the roof, dropped it down a vent, and the idea is anywhere that this stinky smell could be escaping, well, smoke can also escape, but the only difference is smoke is something you can see with a flashlight. And that cleared up the problem in pretty short order. Turns out that someone had tied the restaurant's commercial kitchen stove, tied the vent hood for that, into the sewer system, and that was what was forcing the air through. Well, I think that's one of those problems where maybe when you finish it, you don't actually feel any better when you solve it. And it was around that time. I'm not saying this is what caused Daniel to make the decision. He wanted a new career, but he did decide he wanted to work in a job where maybe he could decide what to smell. Now, Daniel's roommate at the time was in IT, and his roommate recommended something to Daniel called the Cloud Resume Challenge, which is a project I had put out on social media around that time, trying to encourage more people to get into a cloud career by getting hands-on building something with cloud services. And if you've seen the Cloud Resume Challenge floating around on social media, on people's LinkedIn or whatever, you've probably seen these diagrams that they share showing what they built. And imagine being Daniel and seeing this, with zero exposure to tech and reading like API requests, static website, pass requests, a Lambda function. What does that even mean? You'd think that would be just gibberish. But Daniel actually told me something really interesting. He said when he looked at these diagrams for the first time, he said it looked familiar to him. So he went out and he bought a whiteboard. This is a real picture of Daniel's whiteboard. He sent it to me. And this is his first attempt to make sense of what's going on under the hood of the Cloud Resume Challenge. Daniel called what he had drawn an engineered print, because that's what they call it in the trades. He didn't realize he was drawing his very first cloud architecture diagram. Daniel spent the next several weeks learning Python and JavaScript, figuring out how to sling YAML, how to stitch together cloud services to build a website. And in just a few weeks, his website was online, hosting his resume. This is actually still online today. You can check it out at dsresume.com. It's maybe not the prettiest thing in the world, right? I'm sure he wouldn't claim to be a front-end developer, but he did it. He built it end-to-end, full stack, and got it online. And I love the certifications that he has listed there. Check this out. Maybe the greatest set of certifications I've ever seen for an entry-level person in tech. Daniel is certified in plumbing. He's a licensed journeyman plumber. He's certified in backflow prevention and cross-connection control inspecting, and he's certified on AWS. I thought that was fantastic. Daniel told a little of this story a few weeks later in a blog post called A Plumber's Guide to Cloud. This is the final step of the Cloud Resume Challenge, by the way. You have to blog about what you've done. It's one of the most important steps. And in that, he reflected a little bit on why the Cloud Resume Challenge felt familiar to him, why it felt like something that he was able to tackle and succeed with. And these are quotes from his blog. He said, problems are not always going to present themselves in an easy-to-understand way, whether you're dealing with a bizarre error that keeps coming back to your browser, or whether you're dealing with a strange smell that keeps blowing through a building. He said, we tested our setup, talking about the issue in the shopping mall, at multiple entry points and narrowed down our search using outside-the-box thinking. In a way, it was almost like pair programming. He worked with a colleague, they tested different points, they had to test them one by one, they narrowed the problem down. This is troubleshooting 101, right? It's the same thing you do if you're trying to figure out a problem in a piece of software. And he was very familiar with that type of work. Obviously, wasn't easily frustrated by that. He was used to slowly iterating his way toward a solution, eliminating possibilities. And then he said, and I love this, even if you can't find the problem, you can't take downtime whenever you want to fix it. Your client or customer base comes first. That is production engineering thinking right there. I don't care if you're working on plumbing in a shopping mall or if you're working with a database. If there's people that depend on it, you have to take them into consideration. You can't just start turning things off to fix the problem. Okay, I've met people that come out of computer science college programs that don't understand that. Something you kind of have to learn on the job. Well, Daniel had been on the job, and Daniel had learned that. Daniel's blog post, A Plumber's Guide to Cloud, went viral on LinkedIn. It was viewed more than 200,000 times. And it was only a month or two later, in September of 2020, that he was able to start his new career as a DevOps engineer. And from what I understand, he's still crushing it today. Daniel's story is inspiring, but it's not the only story of people using cloud projects to change their careers. And I'm going to tell you a few more of them today. My name is Forrest Brazeal. I'm the head of content at Google Cloud. I actually used to work right here at Pluralsight, at A Cloud Guru, which is now a Pluralsight company. So I'm really passionate about helping people change their careers, transition into tech, transition into cloud. I am the creator of the Cloud Resume Challenge. You can learn more about that at forrestbrazeal.com or on my Twitter at forrestbrazeal. I do have a book that's available in stores everywhere and from Wiley Publishing called The Read Aloud Cloud, which is kind of a friendly general audience's introduction to cloud computing. And it is heavily illustrated with cartoons. And fair warning, there may be a few cartoons in this talk, as there usually are in a talk of mine. So today we're going to be talking about how to go beyond certifications, how to get into a cloud career or advance your cloud career through building projects, kind of like the one we just described. And we'll be very clear up front. I'm not down on certifications. I'm not dissing certifications. Obviously, I used to work at A Cloud Guru. I have several cloud certs. I believe passionately in their importance. And there's it feels like, consulting where certs actually do take on outsized importance. But I mean, let's be real. There's kind of a disconnect right now in tech where, look, you can make a lot of money in cloud, okay? It's a fantastically lucrative career. You get to work on interesting problems. But it sometimes seems like we've got one line for, people that are trying to hire experienced cloud engineers, and there's nobody in that line. And we've got another line of people that really want to get started, and there's nobody looking to hire them. The supply and demand is way off. And so you may have ended up in a situation where, you've walked into a job interview and you do have a couple of certs, but you get slapped down by a hiring manager or even by a recruiter saying, oh, yeah, well, that's great, but come back to us when you get some more on-the-job experience. How? It's chicken or the egg. How am I going to get experience without a job? All right, that's where projects come in. And I want to say, again, certs, they're great. They're a great way to get started. You definitely need to have some, I think, if you're coming to tech, coming to cloud from a non-technical background. It's a really good foundational way to get started. But there are some diminishing returns if you're going to get, cert after cert after cert and not be able to show that you have that kind of production engineering experience like we talked about with Daniel. So a small non-zero number of core certifications mixed with hands-on projects, in my experience, tends to be a better, more solid thing to walk into an interview with. We're going to talk a lot about projects over the next little bit. I'm going to share some things I've learned from the Cloud Resume Challenge community that make a good project, that make a winning project, a project that stands out in a job interview. But I want to start off by mentioning that not all projects are created equal, okay? And so if you've been struggling or you've been having trouble getting people to notice or take attention of your projects or maybe even take them seriously, it might be one of these things. I'm not saying it is, but these are things that I've seen frequently be a problem for people. Like Hello World level tutorials, where you kind of follow a series of steps someone lays out and just kind of copy and paste the commands they give you to build something that was preordained from the beginning of the project. Those are great for learning. You should absolutely do them, but they tend to not be that great for your resume because, again, like you didn't really build anything on your own. You kind of just followed a recipe that someone else laid out. There's not a whole lot of problems that will present themselves to you in an actual job that will be quite that straightforward. So those are kind of hard to list on your resume. Home automation. And don't get upset with me here. I mean, we all love programming our lights and things like that. We love dragging out a Raspberry Pi and figuring out how to control our sprinklers. But the reality is, unless it's some really awesome and specific job that I haven't heard of, your hiring manager probably isn't going to need you to program their sprinklers. So the DIY consumer home automation stuff, while they're fun projects and great to do, and you may learn a lot doing them, they don't always land well in a job interview because they just don't always seem like they translate. And then the last thing I'll bring up, I'm calling them intentionally bad ideas. I'm being deliberately a little bit vague there, but it's kind of hard to take into a job interview something where you've built something that's intentionally overcomplicated, where you've maybe pulled in a bunch of, I don't know, cloud services, or you've used a programming language that you would never use that way in reality. Maybe you've, I don't know, run a website on a fleet of Raspberry Pis just because you could. But hey, just because you can doesn't necessarily mean that you should. And so if you're building a project that you're going to put on your resume and take into an interview, you want it to be something that actually looks appreciably like something someone might build if you paid them to build it. Okay, so that may feel a little bit negative. I just listed off a bunch of things not to do. Now we're going to spend the majority of our time focusing on what does work and what does make a really good cloud project. And there's 3 big things I'm going to call out for projects that win. And the first thing is make it useful. And you might think that goes without saying, right? I mean, anything you build should be useful. That seems obvious. But I find that it's not always quite as obvious because, especially if you're coming into cloud from a completely non-technical background, how do you know what a useful project is, right? You have no professional grounding or experience to say, okay, I mean, is this something that someone would actually use, or is this just a toy project? It's sometimes really hard to have that discernment. And here's how I would recommend approaching that if you're not sure. So if you're not totally coming from a non-technical background, let's say you're working in IT today in some capacity, and you'd like to make that jump to cloud engineering or being a DevOps engineer, but you don't have the hands-on experience with cloud, I would recommend taking some things that you're already doing in your IT career and figuring out how to, if I can coin a word, cloudify them, all right? You may feel like your IT career is something you're rebuilding in flight, and that's okay. Here's how I would say you rebuild that. How to cloudify a skill. First thing, build the thing you know. So let's say that, like I used to be at one point in my career, you're a SQL Server database administrator, and you're trying to figure out how to get to the cloud. First thing I would do, take a SQL Server and just stand it up. I say Google Cloud because I work for Google Cloud, so I have to kind of smuggle in a little bit of a pitch here. But let's say you're just going to go to Google Cloud and stand up a SQL Server there. I'm not saying use any of the managed services. I'm saying go get a SQL Server, just put it on the most basic VM you can find, click around in the console, and just kind of stand back and see, okay, I did that. It looks kind of the same as when I did it in the data center. I can connect to it over the right port, and I can still run the same queries that I'm used to running. And that's step 1. Second step, I would automate that thing. So where you were using ClickOps before, clicking around in the console, now you're going to use some sort of automation to get this thing stood up. All right, you're going to write some scripts to make sure that SQL Server stands up the exact same way every time, initializes the same way. You're going to put your code in source control using something like GitHub. Maybe you're going to build some kind of a rudimentary CI/CD pipeline to make sure that code gets from your laptop to the cloud without any other manual touches in between. Terraform, Git, that sort of thing are your friends. So that's step 2. And then step 3, finally, is I want you to reproduce this thing using cloud services. So instead of just standing up the SQL Server yourself on a VM, now you're going to say, hey, I wonder if I could use this Google Cloud SQL thing to build some equivalent functionality. Or there's this spanner thing over here that's a little different than what I'm used to. I'm less comfortable with it. It doesn't maybe use the drivers that I'm used to, but I can see that it's going to end up with some sort of distributed relational database setup. So I'm going to try that and see what the differences are. And now you've kind of scaffolded your knowledge along with the new things that you're learning, and you've probably gotten farther than you would have if you just started trying to learn managed services from scratch. That's how I would recommend approaching a project if you do have some existing IT knowledge. If you don't, if you're trying to get into cloud or into tech from a background of, I don't know, being a residential plumber, here's how I would recommend going about building your skill stack. All right, and this is where certs come back in, because again, I keep saying it, I'm not anti-cert, I'm not down on certs. I just want to try to put them into their proper place in the hierarchy. So I would start with a foundational cloud certification. This could be something like the AWS Solutions Architect Associate or Google Cloud's Associate Cloud Engineer, something that gives you a broad spectrum of coverage across the basic services and features that cloud provider offers. And then I would layer several pieces of knowledge on top of that. You need to know how to code, all right? Code is the barrier to getting a cloud job. Code is also the bridge to getting a cloud job. It's the reason why people that have been software engineers tend to have an easier time getting hired in cloud than people that have been IT admins, because oftentimes being comfortable and fluent with writing code is the difference between those two groups of people. So you're going to need to know how to write code so that you can automate things, so that you can manage the cloud at the scale that the cloud requires, right? Servers can't be pets anymore, as we sometimes say in that world. You've got to know how to code. Pick a language. Python's a great one if you haven't chosen one already. Go's another great one. A lot of Google Cloud is written on Go. Linux and networking networking. Basic Linux and networking are key things to know. Again, you can do some courses to help you track things down here. You could potentially look at getting like a specialty certification, but I would say don't quite focus on that yet. Just make sure that you basically know the network stack. You understand, IP and the various protocols that build on top of it. You understand DNS. And I'm going super fast here because this is not a talk about, what are all the things you need to know in the Linux kernel or the things you need to know in the networking stack. I'm just calling out this is something you want to be comfortable on. It is going to come up in interviews. And then finally, you need to learn how the cloud services fit together. And the way to do that and to tie in these other skills, Linux networking and code, is to bring in hands-on projects. Okay. So I would build a couple projects that encapsulate those things. And then while you're maybe going after, could be a professional level certification or a specialty cert that kind of dials some of this in a little bit more closely, that's when I would start applying for jobs. Let me give you one thing here before we move on to the next point, which is when you walk into a job interview, the reason that you want to have projects in your back pocket is not necessarily because the hiring manager is going to be so impressed by the fact that you built something on your own. They may be. I mean, I've heard many stories of people that have gotten jobs that way, but it's ultimately not going to be as impressive as, you having 5 years of professional experience somewhere. But what working on these projects does do for you is just the pain of having, beat your head against various problems for multiple days to be able to figure them out and get them working in real life. That's going to cause those solutions to stick in your head way more than if you just read about them in a book or crammed something for a certification exam. If you dealt with, Cert validation for a couple of days, try to figure out, how to work through DNS validation to get a cert renewed, you're never going to forget that piece of that, or it's going to stick in your mind a lot better. And so when you get asked about it or asked to tell a story about a time when you did X, Y, or Z in an interview, that story is going to come to mind. You're going to feel much more confident. So feel that pain. You don't have to love the pain. You can even hate the pain, but you will remember the pain if you've experienced it. That's the real power, the hack behind doing these cloud projects. That's what makes them so useful. Second thing, projects that win. Make it useful, make it accessible. So there's a little bit of a nuanced difference from being useful, to be clear. And I'm not just talking about accessibility in the sense of making sure it works with screen readers, although that's super important and you should definitely do that. I'm talking about it even more broadly. I'm talking about accessible in the sense of you want to create a project that people can understand, that resonates with them, where they get why the problem you're solving is something that, is something that they can get their heads around. I see a lot of cloud projects out there that they're just sitting out on GitHub and it's kind of some inscrutable scripts, and maybe they are solving a super useful problem. Maybe it's exactly the kind of thing that you'd be doing on the job, but how many hiring managers are going to sit there and try to read through this and decipher your uncommented code and figure out what it is you actually did, right? Let's be very real and say probably not a lot of people. So it's kind of up to you to package and present that project in a way that clicks with people, that people understand. This is where full stack engineering can come in handy. Putting a front end, putting a dashboard on your project is super important. It's why it's a key part of the Cloud Resume Challenge, even though there's not a lot of cloud engineers that write front end code, okay? Or maybe there are some. I feel like there's a lot of cloud jobs that don't, but it's so important to have that accessible front end interface on it so that other people can understand what you've built and what it's for. If you're not sure how to do this, you're not sure if you're building something that other people can understand, the best way to test that is to bounce it off of other people. And I think that getting plugged into a community is one of the key advantages that products bring you. I'm going to give you a couple of suggestions here. Number one, get active on Twitter. I know, Twitter's the worst. All right, it's, I pull my hair out on there every other day. But the real advantage of Twitter, especially for people that are early in their careers, is it gives you what I would call an asymmetric level of access to people who are much more influential or much more experienced than you are in the space. You can ask them questions and they will often respond. You can reply to them, you can make comments, you can tag them in things, and it's shocking, how often you'll find yourself having a conversation with someone who literally has a Wikipedia page, all right, about the amazing things that they've done in tech. It's a amazing kind of leveling of ground to be able to speak with people that you would possibly never be in a physical room with. So check out Twitter, get active there, get plugged in, and then join some cloud provider communities. Again, this is where my Google Cloud bias creeps in, so feel free to ignore, but there's a Google Cloud community called Google Cloud Innovators. It's relatively new. It's also relatively straightforward to join the community. You don't have to have a lot of existing credentials to get in there, but it's going to give you some kind of insider access to a lot of the things that are going on at Google Cloud. And if you're interested in that particular cloud provider, I would recommend that. And there are similar communities for the other major cloud providers as well. And then finally, I would recommend learning in public, not a concept that's unique to me, but this is just taking the projects you're working on, taking the discoveries you make, and just sharing them as you go along. I'm not saying you have to become some content creator or some influencer or whatever, but usually the best time to share something, a problem that you've worked on, is right after you've solved it, when it's still fresh in your mind. That helps other people recognize that you're going through problems that they're also going through, which will make them want to come be part of what you're working on. And it also helps you remember things. It helps you remember what you learned, in the same way that, we wanted you to kind of burn in that pain so that it comes to the front of your mind when you get asked a question in a job interview. Writing up what you learn as you learn it will help cement that for you as well. Believe it or not, as I was putting this talk together, I went back and reviewed a couple of old blog posts that I had written, a couple of old YouTube videos I had recorded, because things I had learned about how to make a good project 2 years ago were not at the top of my mind now. But it turns out that going back and looking at those blogs made it very easy to come back. So I highly recommend kind of creating that breadcrumb trail for yourself of things that you've done. I want to talk for a minute, though, here about asking for help, because I get asked a lot about this in the cloud project world, where people say, well, I'm doing something like the Cloud Resume Challenge, and I see there are these steps I'm supposed to accomplish, and I'm not sure how to do them, but I'm also not sure if I should go out on Twitter or I should go into the Cloud Resume Challenge Discord server, and if I should ask someone, how do I do this? Can you give me a hint? Can you share a piece of code with me? That feels like cheating, right? If I was in school, that would be cheating. Well, here's where I remind you that we are not in school here. All right, we are professionals. We are learning together to do our jobs better. And if you're on the job and working with a coworker and you get stuck, actually a big part of your job skills is in not just spinning your wheels and staring at the screen for days and not making any progress. You're probably going to get in trouble if you do that. Instead, if you get to a point where you feel stuck and you don't know what to try, that's when you pull in a colleague, right? That's when you go to your manager and say, hey, I'm really blocked here. Can you help me get unblocked? There are whole structures in the professional world to do that. And as you're building cloud projects, I would recommend not letting yourself get frustrated and stuck on something that you just can't figure out, but to engage with those communities that can help you figure out how to solve it. Even if it means that they, help you write a line of code. That's okay. Again, this isn't school. We're learning together, all right? And over time, as you actually get closer to people and learn from them, you'll learn faster and better than if you try to do it on your own. So don't feel a stigma about asking for help. Just work to build a community so that you have helpers when you need them. Third thing, make your project useful, make it accessible, and finally, and perhaps most importantly, make it yours. Make it your own. I want to share with you a tweet from Scott Hanselman, who I know is a friend of Pluralsight. He says, this is it, Tech Twitter. This is the tip. Not tutorials. Remember we said Hello World tutorials have limits, right? Is something that goes on your resume. But make a thing. Register the domain. Get the cert. And to be clear, here he's not talking about getting a certification. He's talking about, getting SSL working on your site. Get an A on security headers. Submit it to a store. Fix SEO. Add Open Graph. I've spent so much time with various static sites that I run getting Open Graph tags to play nice. It's so frustrating. Features. Make a progressive web app. Run a site 24/7. This is how I know stuff. Run real sites and scale them. Scott's been at Microsoft a long time. He's extremely influential in the developer community. He knows what he's talking about here. So this is a world where you're not just creating a one-off project to solve some contrived problem, but you're creating a website that does something that you need it to do. And I think over time, as you work on a website or a project that has some personal meaning to you, that solves a problem that you actually have in your daily life, you'll be more likely to maintain that site over time, that project over time. You'll be more likely to come back to it and add fixes and features, and that's going to keep your learning going. It's going to help you grow as an engineer. So you want to do something that's your own. And this brings us back to the Cloud Resume Challenge. I mentioned it a bit up front. If you're not familiar with it, you can check it out at cloudresumechallenge.dev. It's a free set of steps that basically gets you to deploy your resume in the cloud, and it brings in a bunch of different cloud services behind the scenes to make that happen. You can do it on AWS, on Azure, on Google Cloud. There's separate sets of instructions for each of those. It's kind of a spec-based project. So it doesn't tell you, run this command, run this command, run this command, and then it's going to be done. It just gives you the outcome of the step. Like, hey, I want you to, store your visitor counter in a database. And then you've got to figure out what database you're going to use and how to write the code that actually does that. So it's quite challenging, particularly if you're new to the industry. You'll see a lot of Cloud Resume Challenge blog posts floating around out there. I mentioned that's one of the steps of the challenge is to start taking baby steps into the community by sharing about it. And you'll see a lot of people sharing architecture diagrams. This is a real one from someone who did an AWS version. I just pulled it off of their blog. And you'll see this is what's being done behind the scenes here. So there's a front-end piece where they're deploying to S3. They've got CloudFront, which is a CDN, a content delivery network in front of that. They've got some DNS going on. They've got a little CI/CD workflow behind the scenes that involves GitHub Actions, as well as AWS SAM, which is an infrastructure as code tool built on top of CloudFormation. And they've got a little back-end piece, right? That's DynamoDB, Lambda, and then what we call API Gateway. And all those things are tied together in one full stack cloud project. It's very cool if you can get this working. But I want you to notice something here. What's shown on this slide is what anybody could produce given the spec that's in the Cloud Resume Challenge. So if you want a great story to tell in a job interview and you want to make the Cloud Resume Challenge part of it, I would recommend going farther than what's shown here. I would recommend finding a way to extend the Cloud Resume Challenge in a way that's unique to you. And there's lots of ways you can do this. A couple examples I'll give you. You could add additional API authentication and rate limiting to it. The standard spec for the Cloud Resume Challenge is pretty open in that regard. You could build some monitoring on the back end so that you get pinged when something goes wrong. If that Lambda function stops working, you might want to get an email about that so you can go in and fix it. You could build out a multi-step CI/CD pipeline that not only has one production environment where your code lives, but also has like a staging environment where you can deploy changes to make sure they work right and build hopefully some automated tests to ensure they work right before you push that change onto production. All these are kind of more mature, cloud architecture practices that you'll see show up on the job. But if you build these things into your own site, and if you maintain that personal site over time because it's meaningful to you, you'll be able to add more of these things and you'll have more unique stories to tell in a job interview. Like, hey, there was that weird time when my cert expired and my Lambda function stopped working and I got pinged and then I was able to go in and fix it, right? That's a great story to tell. And it's something that only happens if you're keeping an eye on this site and maintaining and investing in it over time. Let me leave you with this for this part of our conversation. Projects are not just something you do because you're hopeful that they will crack a magic code and give you access to jobs. All right, there's going to be a lot more to it than that. But one of the things that projects always do is they help you figure out if you enjoyed working on the project or not. All right, you may find yourself discovering that you don't actually like working in cloud as much as you thought that you might. It's actually a really good thing to know before you spend a whole bunch of time, prepping for and interviewing for jobs that you may end up hating. All right. Projects help you figure out what you enjoy. That's a personal value they have to you. And so that's why I highly recommend trying them before you make the big step of making a career change. I always love sharing this tweet, and I promise I'm not doing it to pick on this guy, Cesar, but this is something that he shared back when I originally announced the Cloud Resume Challenge, right at the beginning of the pandemic, April of 2020. He says, what's the over-under that a person who met your pre-qualifications will actually complete the whole steps? My pre-qualifications, by the way, were that you couldn't have existing background in cloud. I wanted to see people try this from totally non-tech backgrounds. He says one person. He thinks a grand total of one person would be able to do that. And he says, I hope I'm wrong. And I'm happy to say, I take no undue pleasure in this, but it does make me happy to say that Cesar was wrong, and that thousands of people have attempted the Cloud Resume Challenge. Hundreds have completed it, and we've seen dozens that have actually gone on and leveraged that as key parts of getting hired in cloud. Now, that's a kind of a winnowing down, right, of numbers, and that's because it's a difficult project. And a lot of people try it and realize, oh, this isn't really for me. I didn't really want to do this. But that's good learning too. Again, that's part of why this is out there. And I'm so excited to have met folks that are in retail, that come from banking, that come from HR, that come from legacy IT careers where they weren't getting to touch the cloud in their daily work, even people who were, commercial plumbers, all folks that have used the Cloud Resume Challenge to find new roles in tech. And I want to finish up kind of tying all this together by telling you about one of my favorite of these side projects, the side project that made the front page. And we're going to kind of use this as an opportunity to go back through our key points of what makes a good project. We're going to notice how they stand out in what I'm about to show you. Let me introduce you to one more person. His name is Jacob Andre. Jacob was a combat medic during the Iraq War. After the war, he came back to the U.S., got a biology degree. I believe he went on to get a master's degree as well. And he spent several years as an infectious disease researcher at Lurie Children's Hospital in Chicago, working on HIV/AIDS, and then eventually, in the very early days of the pandemic, working on COVID-19. In early 2021, Jacob decided that it was time for him to make a career change, that he wanted to become a DevOps engineer. Jacob knew that he wanted to build something useful. All right. He wanted to build something useful. And the way he went about getting hired in cloud, he got several cloud certifications. Again, not saying they're bad. They're very good. That was the right place for him to start. He did the Cloud Resume Challenge. That's how I got to know him. But he went beyond that a little bit. He was looking for other projects to do. And so he did a project that I had created back when I worked at A Cloud Guru, which is now a Pluralsight company. We had created this set of projects called the Cloud Guru Challenges. And they were kind of spin-offs of the original Cloud Resume Challenge. They used a similar format. And the idea was to see if we could extend this to other types of cloud learning. And so I had created this project called Event-Driven Python on AWS, which was an attempt to get you building an ETL pipeline. If you don't know what ETL pipeline is, it's ETL stands for Extract, Transform, Load. And it just means, hey, we're going to take some data from somewhere, we're going to do something to it, we're going to change the way it's formatted somehow, and then we're going to push it off to some other data repository somewhere else. Sounds kind of boring on the face of it, but like a huge amount of cloud engineering work or data engineering or DevOps engineering is built around those exact type of problems. We've got some data, we're going to munge it, we're going to put it somewhere else. It's just bedrock useful stuff that cloud engineers do all the time. And to make it a little more interesting, the data sets we were using were COVID-19 data sets from Johns Hopkins. So we were looking at daily case counts. And you can see the note from the blog here. You can check this out. It's still live. You can do it yourself today if you want. So Jacob decided to take on this COVID case tracker project. It was interesting to him because he, had some clinical background working with COVID-19. And he did. He built it out. But he didn't just build out this project. He decided to make something that was easily accessible to other people, that others could look at as well. And so he built a website. It's called cpscovid.com. Again, it's live. You can check it out right now if you want, where he surfaced this daily case data that he was discovering. Would Jacob tell you he's the greatest front-end developer in the world? I'm sure he wouldn't make a claim to do that, but it's easy. You can, actually interact with it. You can see what's going on. You don't have to be a super technical person to appreciate the value of this site. You could be a school teacher, you could be a parent, you could be a hiring manager, and you can easily see that this is something worth doing. So it took him some time, obviously, but he was able to put this together. And not only did he make it useful and accessible, Jacob took some steps to make this project his own. He didn't actually use the data sets that I recommended in the project. It was COVID-19 data he was looking at, but if you've been to cpscovid.com, you've probably figured out that the CPS part stands for Chicago Public Schools. Jacob lived in Chicago. He has children in the Chicago Public School system. So he decided to scope down his website to just tracking cases in the Chicago area. And what that did was it enabled him to build something that was personally meaningful to him, something that he wanted to check every morning when getting out of bed and figuring out how to send his kids to school. And that enabled him to keep working on it over time. It won't surprise you to know that Jacob got a DevOps job in pretty short order. I think he's a DevOps engineer at Yellow now. But he kept running his site because he built something that had use to him. He was able to keep pushing out updates to it, keep learning, running this on the side. Around the beginning of the new year, so January of 2022, Jacob noticed something strange. See if you can spot it here. This is a graph that he had pulled out of some back-end number crunching he did on the site. There's two lines here, the red line and the blue line. And notice the red line is showing the number of cases overall in the district where he was living. And then the blue line is showing cases that were popping up in the school system. And those lines basically tracked each other identically right through the end of calendar year 2021. But just after the calendar flipped over to 2022, notice something changed. What changed? Well, the district cases shot way up, which should make sense because we hit a huge COVID wave right around the turn of the year here in the US. But the school cases stayed the same. In fact, they actually went down, way down. This didn't look right to Jacob. So he kept digging, poking around in the data, and he eventually came to the conclusion that, he couldn't say exactly why it was happening, but he believed that the Chicago public school system had actually changed the way they were reporting data to make it look like COVID was not as prevalent in the schools as it was. And, again, can only make assumptions, but this happened to be at the same time that the Chicago school administrators were in a deathly fight with the teachers union over going back to in-person learning. So you could start to construct some ideas about why this might have been happening. Jacob took to Twitter through his CPS COVID account to share a thread about how Chicago Public Schools has been, in his view, intentionally deceiving parents and the public about COVID numbers. And he brought receipts. If you go down through that thread, it's just an endless series of screenshots from his dashboard showing how the numbers pretty clearly were being fudged. Well, before long, Jacob's story was everywhere. Newsweek picked it up, Chicago Sun-Times. The Chicago Public Schools were compelled to respond after the alderman in the city began raising concerns about it, saying that, well, they didn't intentionally mislead people, but they couldn't argue with Jacob's data. It was pretty clear that they had changed the way they were doing the reporting. Jacob went on national news asking for an apology over the misleading data. And while Chicago Public Schools never admitted to intentionally changing what they were doing to mislead, I will say they're not able to mislead parents in the Chicago area anymore because every news outlet in Chicago ran screenshots from Jacob's dashboard. Let's step back a second. Remember, Jacob wasn't just a cloud engineer. He had significant background in clinical research training, and those two things combined helped him to spot a public health issue that nobody else had noticed. Think about Daniel Singletary, who we started with. His background in the trades, his production engineering experience, if you will, combined with his cloud chops to make him an operations superstar. So that brings it back to you. What's your superpower? What's your unique combo of skills? What have you done in the past? Where have you worked that you can combine with cloud to not only level up your own career, but potentially have some impact on society? These are questions you can answer through a cloud project. These are questions that can guide you to the right next step in your career. So I want you to sit and think for a minute, how can you put that combination of skills in practice today? I truly believe that the world needs you. The world needs the skills that you bring, the value that you provide. All right. And cloud projects are a great way to start with that. I can't wait to see what you're going to do. Thank you so much for taking the time to listen today. Again, my name is Forrest Brazeal. I share lots of these stories about cloud projects on my Twitter at Forrest Brazeal. You can follow me there. And then if you're interested in trying the Cloud Resume Challenge or any of those other Cloud Guru challenges that I mentioned, they're all linked at cloudresumechallenge.dev. They're free. You can try them today, and I hope that you will. Thank you so much.
So many thank yous to both of our keynote speakers. Scott Hanselman and Forrest Brazeal are both absolutely incredible educators. I feel really, really fortunate that I'm able to learn from both of them and that we were able to bring them into this event to share their experience and their advice. I am also really happy to have my colleagues Lars Klint and Jeremy Morgan joining me.
Hello.
Hi.
So before we transition into the tracks, I want to add to something that Scott said about mentoring, and y'all jump in with me if you have opinions. But I wanted to add that you don't need to have a formal relationship with somebody to benefit from their knowledge and from their experience. When you find people that you admire who are doing the things that you want to do, listen to them, read what they write, try the practices that they advocate, explore the communities that they love. And, like Forrest said, get active on Twitter, that kind of thing. Having those kind of connections in public can be huge.
Yeah, absolutely. I actually make a list of a lot of the people that I follow online, and I follow their career and things. I kind of make a list of things like, this is something that they did really well, that I really like. And then I also make a list of, these are some things that work well, but I don't think would work well for me. Like just knowing my personality and how I work, I'm like, this works well for this person, but not so much for me. And then I keep, a list of the things that I think work well, like, oh, this particular presentation style is really cool. I might try to adopt that or whatever. And you can absolutely do that, like you said, without any kind of personal relationship. You can just watch what they do and emulate what you like, and no, don't emulate the things that won't work for you. So
I just copy Jeremy's lists.
It's good to have a Jeremy in your corner, for sure.
Right.
But yeah, if y'all wouldn't mind, so Lars, you're going to be guiding folks through the cloud skills track. Jeremy is going to be hosting the developer skills track. I've had the privilege to welcome folks into Tech Skills Day, talk us through the keynotes, and I'm really looking forward to meeting folks and talking with, hopefully, many of you folks in the Pluralsight community as I grow into my new role here. But Lars, Jeremy, if you wouldn't mind introducing yourselves.
Oh yeah, good plan. We should do that. So hi everybody, I'm Lars, and I'm in Australia. I know. So yeah, it's like, I don't know, what is it, like 4:20 a.m. or something here, but that's okay because I'm here with all you guys. So this is what I do. I enjoy it. I love it. So I'm Lars Klint. I'm a Pluralsight oh God, what's my title now? Developer evangelist? I think that's what we're called now. It doesn't matter. We help all the learners do all the things that you want to do, really. We're just here to sort of guide you and help you. But I'm a Microsoft MVP. I do live in Australia, in rural Australia of all places. So I'm going to preface this, say, hey, I'm on Starlink. If I drop out, it's Elon's fault. Can we do that? Is that fair? Yeah,
let's go with it.
But yeah, I've been doing this forever. I love these live streams, and I love this sort of interaction with the actual learners. So put all your things in the chat, right? Wherever you are. If you've got questions or whatever, put them in the chat, and Matthias will answer them probably, but some of us will answer them. But yeah, I think that's enough waffling for me. I'm just going to pass it over to Jeremy, who has way better hair than me.
Thanks, Lars. So I'm Jeremy Morgan. I'm a developer advocate for Pluralsight. And I am outside of Portland, Oregon. I'm also in a rural area, but I'm outside of Portland, Oregon. So if you guessed that it's raining outside right now, you'd be absolutely correct. So I'm a senior developer evangelist. I like to call myself the world's okayest developer, and I love helping developers get better at what they do. So I love what I do every day, and the Tech Skills Day is such a huge part of that. And so I will be doing the developer track. And what we're going to do is jump into a 10-minute break, and then we're going to get started on the developer side. So
yeah, join us.
Join us, yeah. As Lars said, jump in the chat. We will chat with you, and this will be a fun, interactive hangout situation. Hopefully.
All right.
See you soon.
Welcome to the developer track. So up next, we have David Neal. Now, David's a family man, musician, illustrator, software developer, and Microsoft MVP. He's living out of North Georgia. He's one of my teammates here at Pluralsight in our developer evangelists group. So he's currently a developer advocate for Pluralsight, and he runs on a high-octane mixture of caffeine and JavaScript, and is entirely made of bacon. So today he's going to be presenting JavaScript, past, present, and future. And it's a really cool kind of history lesson of JavaScript. If you understand where it came from, it really helps you to understand where it's at now and where it's going. Now, afterwards, we're going to jump into some Q&A for this. So let's go ahead and get started with David Neal.
Hey, y'all. I'm so excited to be joining you for Tech Skills Day 2022. And this is my talk on JavaScript. Now, JavaScript has been around for a while, and it's burned a developer a time or two. JavaScript has caused more than its fair share of indigestion for many a developer. And my first introduction to JavaScript was around 1997. At the time, I was a Visual Basic developer, and I started building web apps with ASP or classic ASP. And I kept reading about people doing DHTML, and I wanted to learn how to make my websites more dynamic. You know, dynamic cursors and alert boxes, rollover buttons, objects that bounce around on the screen. You know, the more obnoxious, the better, right? And things started to really get serious when I joined a hot startup right before the dot-com bomb in the early 2000s. And I was tasked to build an interactive commercial web app that needed to support both Netscape and Internet Explorer. And it seemed like so many cool companies were having great success with JavaScript. I wanted to be a cool developer, but it sure was a struggle to learn. And there was a lot of trial and error and not a whole lot of documentation or help available. And you know, with JavaScript, anything goes, and it often does. If you were a web developer around this time, you probably remember sites like Dynamic Drive. I spent countless hours trying to understand the JavaScript code that I lifted from these sites and tried to get them to run in my applications. JavaScript is amazing, except when it isn't. There are quirks and weirdness in the JavaScript language that continue to exist to this day. There's unexpected behavior that can baffle even the most seasoned JavaScript developer. There are still times when I'm writing code and have to scratch my head thinking, why is this behaving why it is? JavaScript's been around for a long time. Why? And people who are developers and who are working on the language are smart people, right? Why haven't we fixed these things? How did this happen? Well, JavaScript, arguably the most popular, most ubiquitous, universal, pervasive language in computer science history so far. If it's so important, why is it still kind of terrible in places? Well, the birth of JavaScript is the classic example of how so many things get created in the software world. It's funny, but it's the kind of funny that makes you want to cry. This is Mark Andreessen. He was at the University of Illinois and was one of the people who created the first internet browser, NCSA Mosaic. He moved to Silicon Valley and helped start a little company named Netscape. In February of '95, Mark hires a man named Brandon Ike. He was hired to create a scripting language for Netscape. The original plan was to implement Scheme, a dialect of Lisp. So in May of '95, thereabouts, with a little bit of, creative drama, Andreessen calls in Brendan and says, "Brindle Pants, we need a demo of that new scripting language, like yesterday." "It's Brendan, sir. Sure thing. Scheme in Netscape is going to be awesome." Oh. Brandy Farr and me are hilarious. Scheme in the browser. Seriously, though, it's got to look like Java. Let's call it Mocha. Yeah, Mocha, Java, get it? We need a demo by the end of next week. I'm going to need you to come in on Saturday, okay? Sunday, too. So you know what Brendan does? He does what any of us would do in this situation. He works like a heroic machine throughout the days and nights, and 10 whole days later, he delivers Mocha. The first version of JavaScript was created in 10 days. That's both incredibly amazing and kind of terrifying. Good work, Boogaloo. Ship it. But sir, it's only a demo. I still need to ship it. Well, you've seen this before. It's the most classic move in all programming. Ship it. Mocha was supposed to be for amateurs and designers anyway, so who cares if it's a little bit buggy? The real professionals are going to use Java. Java is the future. Oh, Java. It was supposed to be the language for the web. But that's not how it played out. Okay, let's fast forward a little bit on the timeline. Microsoft reversed engineered Internet JavaScript and called it JScript because JavaScript, the name, was copyrighted or trademarked by Sun. And they did such a great job of reverse engineering JavaScript that it included all the quirks and the kind of ugly behavior that was in the language. So Netscape, knowing what Microsoft was up to, probably, was going to seek to change it or destroy the language. They decided to go on the offensive and attempt to standardize the language. So they talked to the most obvious candidate, the W3C. The W3C says, no thanks, we have more important things to focus on, like marquee and the blink tag. Keep up the good work, W3C. So Netscape turns to a standards organization based in Stockholm, Sweden, called ECMA International, which stands for European Computer Manufacturers Association. And they create a steering committee called the TC39 to review this language spec. They create a document called the ECMA 262, which is the formal language spec for JavaScript. And since JavaScript is trademarked by Sun at the time, they couldn't use the JavaScript name. So they named it ECMAScript. ECMAScript is the language specification. JavaScript, as it's found in browsers and other technologies, is just one of several implementations of the standard. So the JavaScript language continues to evolve. In 1999, we got ES3, which had some better regex and try-catch error handling and some better string handling. And ES5 added strict mode to guard against some of the quirkiness of the language. They added JSON library support. ES6 was a major update with classes and generators, arrow functions, and promises. But hang on a second. What? There's 10 years between ES3 and ES5. A little bit of backstory. So Microsoft won the first browser wars with IE6 around 2001 and basically sat back to watch the world burn. Microsoft won, but web developers lost. By 2008, ES4 was so big and complex, and there could be no consensus made among all the members of the TC39 for technical or political reasons. So an important decision was made to scrap ES4, take some of the changes that were marked for ES 3.1 and rename that to ES5 and create a path forward from there. So 10 years between ES3 to ES5 and another 6 years to ES6. The TC39 needed to fix their process. But adding new features to JavaScript is not a trivial task. It's not easy being in the TC39 because the first rule of the JavaScript Fight Club is don't break the internet. Backwards compatibility has always been one of the highest priorities when making changes to the language, which is why some of the quirky behavior still exists. If it continues to exist on purpose, it's codified in the spec, because if they fixed it, it would break all the code on the internet that expects that behavior. The internet would collapse and the world would explode. I submit my hypothesis that the Death Star's superpower is a very powerful JavaScript emitter. The TC39 is made up of developers, implementers, framework authors, academics, anyone who has a stake in the JavaScript language. The ECMA 262 specification document is now more than 1,200 pages. And since 2015, the TC39 has been on a better process of meeting every couple of months. They meet for several days at a time. Their discussions are time-boxed, and the entire process is open. You can follow their progress through their repos and their meeting notes. In order for a new idea for the JavaScript language to make it into the ECMAScript standard, the idea has to be moved through a series of 5 stages. Stage 0 is the idea stage, known as the straw man stage. Lots and lots of ideas get submitted at stage 0. Stage 1 is a formal proposal. There's an agreed upon first draft. Proposals essentially state what the problem is, how it might be solved, some of the known technical challenges, and a proof of concept is created. So the stage 2 is where the details are worked out. A formal specification draft is created, the syntax and semantics are worked out, and also backwards compatibility is taken into account. Stage 3 is the candidate stage. This is where we see like Chrome add new features to the V8 engine behind feature flags, or Node.js use feature flags to beta test new language features. Now, things that make it into stage 3 are really close to being done, or really close to being, part of the JavaScript language, but there's still no guarantee that they'll ever make it out of stage 3. Stage 4 is basically the last and the finished stage. There are acceptance tests that are added to the Test 262 project, and the cadence that the TC39 has been on since 2015 is the stage 4 selections are voted on and made in January, and the new edition of the ECMA 262 document is published in June. And that means ES 2022 is imminently upon us. In 2022, we see some things like a new @ function for specifying, getting values in a specific index from an array or a string. There's top level await, which is really great for people who are building command line applications or scripts. And there are new static and private class members for classes, like private properties and private methods. So the yearly update cadence is working. There's more and more new features added to the language every year, and it continues to get better. Atwood laws state that any application that can be written in JavaScript will eventually be written in JavaScript. And that prophecy is no more true than when we see things like emulators that are entire operating systems built with JavaScript. There are so many things you can do with JavaScript, but that doesn't always mean you should. All shenanigans aside, you can do some pretty amazing things. So JavaScript can be challenging, but it's getting better all the time. And so here are some of my thoughts on the future of JavaScript. In the life of JavaScript so far, we've seen the language evolve and be influenced by a number of other languages, libraries, popular browsers, and other technologies. We're starting to see some exciting new tools like WebAssembly. There's some confusion around WebAssembly. It's a powerful thing, but it's not a replacement for JavaScript. It requires JavaScript. It's designed to complement JavaScript. You may have heard of Blazor, which is a way to create single-page type applications using .NET and Razor templates, and it uses WebAssembly. And I imagine there will be niche apps that really take off with it, but similar to Flash or Silverlight or other attempts to abstract the web, I personally don't see it as a sustainable alternative to just plain HTML, CSS, and JavaScript. If you already hate building web apps and try to avoid using HTML, CSS, and JavaScript, Blazor is probably not going to change your mind. In the past few years, TypeScript has gained a lot of momentum. TypeScript seems to be becoming the standard for a type system for JavaScript. And if you listen to TypeScript believers, you might be convinced that it solves all of the problems in JavaScript. But, in the real world, TypeScript solves some of the problems, but not all of them. It also introduces, some amount of friction, and the percentage of bugs that it does fix is relatively small compared to all the other kinds of bugs you might be introduced into your application. Now, I appreciate what TypeScript does. For large-scale JavaScript applications, I appreciate that it gives us a type definition system. It turns out any language, whether it's dynamic or statically typed, it can't save you from making mistakes. And so you still have to be really diligent about the work that you do. I recently had a conversation with a developer who said after 2 years of TypeScript, they wish they could go back to using just plain JavaScript. Still, there are benefits, and you may be using TypeScript today and having great success. I expect to see the good things of TypeScript start to make their way into the ECMAScript standard. And I find it interesting that there are members of the TC39 who are vocal about using TypeScript. And, as new features are added to JavaScript, I wonder if in the future there will still be a strong case to use TypeScript. Well, regardless, I believe there's a strong case for investing in JavaScript. There's good, it's powerful, it's flexible, it's everywhere, and all the positives, I believe, outweigh the negatives. The language has improved tremendously in recent years, and the tools and the technologies and the frameworks and all the stuff that are available continue to get better and better. And I believe all of it is going to continue to get better and better. Thank you, JavaScript, for enriching our lives and for keeping us on our toes, for making us humble when we're tempted to believe that we have it all figured out. Last, I believe all of us in technology have an incredible opportunity and responsibility to make a positive impact on our workplaces, our community, and the world. I challenge you to take the things that you're learning, you share your experiences with others, and you help make our world a better place for everyone. Wherever you are, I hope you stay safe. Cherish the time you have with your loved ones. Make the most of your gifts and your talents that you're blessed with. and be awesome. Thank you.
All right. So that was a great presentation, David. I really liked the storytelling and the diagrams and all. That was just really cool. That's a great way to make JavaScript interesting, at least the history of it.
Yeah, well, try to make it at least entertaining. If, we get frustrated and have to battle with the language, you might as well have some fun with it.
Yeah, exactly. So we do have some Q&A here. My first question here is from Denise and says, I'm trying to be proficient at Java, but is it recommended to learn JavaScript? That's a really good question.
Oh, well, those two get mixed up a lot. It's really, they sound similar, but it's really apples and oranges kind of a comparison. JavaScript, the syntax may look familiar, may look somewhat like a C-style language like Java or even C# or C, C++. They all kind of share some of the same syntax-looking constructs, but the languages are really, really different. If there's any consolation, it's kind of easy to work with JavaScript because it's you can find it in the browsers, you can play around with it on your computer locally without having to install a lot of stuff, and you can learn some fundamental concepts of programming. But I don't think if you got good at JavaScript that you could easily, get proficient with Java. You would still need to learn the Java's way of building applications and the frameworks and the libraries and everything that's part of the Java language. So if the goal is to learn Java, you probably should start with Java.
Yeah, absolutely. And that's one of those two things where they both get confused all the time. And then, of course, people say, like, you should learn Rust, but you should also learn JavaScript. So when you build a Rust app, you'll know. So, yeah. That's a really good question.
And recruiters do it all the time. It's like, must have, 10 years of, I get recruiters reaching out to me for jobs that use Java. I'm like, I'm not a Java developer. Java and JavaScript, they're the same thing, right? No.
All right, so another question we have here. If I want to be a front-end developer, should I start by learning React or Angular or something and learning JS as I go, or should I start with JavaScript first?
That's a very good question. I would say it's definitely beneficial to get some JavaScript language under your belt before you start to learn a front-end framework. Otherwise, some of the syntax might be a little bit confusing or may not quite understand, what all is happening or what the language is doing as opposed to what the framework is doing. One of the workshops that I've run many times is a workshop on Electron, and there's some Electron is a way to build desktop apps using JavaScript. And I tell folks in the workshop that, hey, we first need to look at the fundamentals of how Electron works before we start to look at some of the libraries and the plugins that make Electron easier. Because if we don't, then you're not going to know, well, what's the framework doing, and what part is Electron? Where can I figure out how this is working? So, yeah, I would definitely recommend that you get some JavaScript fundamentals first so that you know how to use the language, and then dive into whatever front-end framework you think looks exciting.
Awesome. Yeah, that's a great answer. Another question we have here, is it better to learn languages that compile to JavaScript, like TypeScript, or ES JavaScript itself?
My opinion is similar to the front-end framework, is it's useful to know the language first, to understand how it works, so that in the process of maybe using TypeScript or some other language that transpiles to JavaScript. It could be like Elm or ClojureScript, or there's lots of options out there that that transpile to JavaScript. I would say, again, is if you're missing some of the fundamentals of the language, then it's going to be a little bit harder and more frustrating to know what that transpiler is doing for you, and to know how best to troubleshoot something, or to I think going the other direction where you learn JavaScript first and then you pick up one of the other things will help you to really appreciate what those other things are doing for you.
Yeah, that's a great point. And so we've got a couple of questions along that stream, and one of them is it better to learn JS before diving into TypeScript? But it seems that's pretty much what you just answered. So
yeah.
And here's a question: if starting out, what kind of JavaScript project should I start with? Like building, I'm assuming like building some kind of demo project to learn.
Yeah. Well, I think that really depends on what you find exciting. There's lots and lots of different learning paths and ways that you can learn the JavaScript language. The cool thing, as I talked about in the presentation, is that JavaScript is everywhere. If building a website sounds interesting to you, then use that as your playground for learning the language. If you think building a desktop app would be cool, you can do that with Electron and learn JavaScript along the way. Mobile applications, there's lots of mobile frameworks that use JavaScript and so if you think, hey, it would be a lot of fun to build an app for my phone, like my wife needs an app to keep track of lists and things of things to do. Make that a fun project to learn with. I build a lot of command line applications using Node because I find ways of like, I could automate this by writing a command line app to do all that work for me. So I can just type in a single command and have it do all the work. Then I'll create a Node.js project and add a bunch of JavaScript as like my script to do the work, and have it go fetch some data from APIs, put that together, maybe create a report or create files locally. There's the possibilities are endless. So it really depends on what's going to keep you excited about learning.
Yeah, great point. So I think we've got one more question here, and that'll be our final one. With there being so many languages out there, should you be proficient at one language and then grow from there?
Well, I'm a fan of Scott Hanselman, and I think one of the things that he talked about in his keynote is spot on. It's like knowing a little bit about a lot of things and then going deep in one thing is a very valuable thing to have in your career. So knowing a little bit about multiple languages and how they approach things differently, how that, the way they're designed is, every language is designed with a problem in mind. It's designed to solve a particular set of problems and do that really well. So JavaScript, has evolved to be like really good for anything web related, but there's other languages that are great for a particular use case. And I think learning a little bit about several things will help you to be a better programmer in whatever language that you decide to go deep.
Awesome. So that's great answers. Thank you very much, David, for doing this Q&A and this talk. It's been really great. So for the viewers, we're going to jump into a break and we will be back at 3:10. So we will see you there. All right, welcome back, everybody. So my next speaker has his head in the cloud all the time, and that's a compliment, actually. So Ned Bellavance is a technical educator, Microsoft Azure MVP, a Pluralsight author, HashiCorp ambassador, podcaster. The list goes on and on. He's an IT pro with over 20 years experience in the field. And today he's going to be talking to us about building your first Terraform module. So I'd like to welcome Ned Bellavance.
Hey everybody, welcome to my Tech Skills Day presentation. My name is Ned Bellavance, and I'm going to be talking about building your first Terraform module. Let's start with the why. Why would you even do such a thing, build a Terraform module? Well, the core idea behind Terraform modules is the software idea of don't repeat yourself, or dry programming. This is a very common concept within software development. And the essential idea is, if you are doing something in code that you're going to do more than once, instead of copying and pasting that code a bunch of times, instead, why don't you create a function or a library, or in the world of Terraform, a module that does it for you. That makes it easier to maintain. If you have to update something about that code, you update it in one place, the function or the library, and then everything that uses that function or library will automatically use the new version. It also makes your code a little bit cleaner. That's the core idea behind Terraform modules. Now, when it comes to Terraform modules, there are essentially two reasons to build a Terraform module. The first is because you want to group a set of logical components together. And I have a great example that we're going to get to in a moment where I had some logical components that really belong together. That's the first reason to build a Terraform module. The second reason is that you want to bake in some defaults or best practices for people who are going to be using your module. If you work in an organization and you have some folks that are going to be consuming the modules you write, you might want to bake in some best practices or some recommendations from your security team into that module so the person using it doesn't have to think about it too much. Now, let me describe a module that I recently wrote and why I wrote it. See, there is the concept of a service principal in Azure Active Directory. And you would think that would be a single resource that you would invoke in Terraform when you needed a service principal. And I needed them fairly often for different things I was building. But it's not that simple. There's actually three components that make up the service principal you want to consume. It's built from an Azure AD application, and then the service principal object itself, and then you're probably going to want a password or something associated with that service principal, and that is represented as a secret. So those are the three main components I needed to go into my Terraform module. You can also do client certificates instead of secrets, but in all of my use cases, I'm using a secret, also known as a password. So those are the three components that I wanted to group logically and maybe apply some best practices as well. So what actually is a Terraform module? It's probably important to define that now that we know we want to build one. A Terraform module is very simply a directory that has one or more Terraform files in it. That's it. That's the big idea. A Terraform module could literally be a file main.tf with some Terraform resources in it, in a directory, and you've written your first Terraform module. Now, you're probably going to want to pass some information into that module, and that comes in the form of input variables. Likewise, you're probably going to want to get some information out of that module, and that takes the form of outputs. Everything else that exists inside of that module should be somewhat of a black box to the person using it. They give these inputs, certain resources are created on their behalf through the module, and then they have access to these outputs to make use of those resources somewhere else in their configuration. Now, the thing that I've seen as best practice when it comes to building a module is to actually break up your configuration into multiple files. The most common ones that I see is a main.tf that has your resources in it, a variables that has your variables in it, outputs for outputs, and version to define the required version of Terraform and the required version of the provider. We'll take a look at each of these in a moment. But first we have to ask ourselves, some fundamental questions about the module itself. And this gets down to some key questions about just software development in general, but specifically about Terraform modules. The first question to ask yourself, and I'll answer these for my particular use case, is who is the consumer? Who's going to be using this module? Now, in my case, I'm the consumer, so I can't answer all the questions about how this module should be designed. But if you're working in an organization where you're building a module for other folks, you need to talk to those people and get some key questions answered by them. The first one is, what do they actually want created? You might think you know, but before you talk to them, you can't be sure. Now, in my case, I'm building it for me. So I know that what I want created is a service principal with a password, and that's going to need an Azure AD application. I don't actually care about that. It's just something that has to exist before the service principal does. So that answers my first question. The next question is, what inputs are going to be given to the module? What can I expect as inputs from the person consuming the module? Now, again, in my case, I can ask myself that question, but you should go ask the consumer of the module if it's not you. What inputs do I need to supply? Well, I'm probably going to want to give the service principal a name, so I'm going to pass a name value. And then I also know that I can set an expiration date or a duration that the password's valid for. So maybe I want to be able to specify a duration, or maybe I want to be able to leave that blank. So that's going to be an optional input. So we'll get to that in a moment. Those are my inputs. I got 2 inputs. And then what outputs do they need? Well, in my case, in terms of outputs, I don't know what attributes I'm going to want from that service principal. So ideally, I just want the whole service principal object with all of its attributes, in case I need something that I can't tell you right now. The other thing I need is the password that gets generated, because I'm going to need to use that somewhere else in my configuration. Awesome. So we've answered our key questions. Now let's review what actually goes into the files. In the main.tf file, we're going to have our resources. And this is also a good place to put data sources if you're using those in your module. And as I indicated before, I've got an Azure AD application, a service principal, and a service principal password. And you can see by the arguments here, I'm referring to some variable inputs, like the service principal name is going to define the name for the application. The service principal will inherit that name from the application, so all it needs is the application ID. And then the password, I'm going to reference the service principal and then also set a end date relative, which means I can specify I want this password to be valid for 30 days or 30 minutes. It's really up to me. So your resources are going to go in the main.tf file. In the versions.tf, you can define a required version of Terraform that's supported. When you're building your module, you're going to test it with a certain version of Terraform. And if you know for a fact that earlier versions of Terraform just aren't going to work with it, you can set a minimum version, say, this is only supported on Terraform 1.0 or greater. And that will prevent folks from using the module if they're using an older version of Terraform that just wouldn't work. Kind of the same thing for the version of the providers. You can say, I've tested this on major version 2. Whatever of the Azure AD provider, which is exactly what I'm saying here. And then if someone wants to use an older version of the provider, they know that this module is not going to work for them. And in fact, major version 1 of the provider didn't have that password resource in it, so it would not work. I'm setting a version here of 2.0, so it stays on major version 2. Moving into the next file is variables. And I want to point out a few things here. When you are writing up your variables for your module, you want to have a really good description for 2 reasons. One, you want a good description for yourself or whoever's consuming it when they look in the code for the module. But 2, if you publish your module to a private or public registry, the documentation that gets automatically generated for your module is going to include the description for each variable. So you're kind of writing docs for the person who's going to consume the module by providing a good description. So I've done that for both of these variables here, and these are the two inputs I want to define. One is the service principal name, and the other one is the duration that the password should be valid for. Another thing that I'm noting in my description is whether the variable is required or optional. Required variables do not have a default value. I'm requiring you to supply one. The other optional variables do have a default value. In this case, I'm setting the default to none, which will set the duration of the password to not expire ever, basically. So right now that's baked in, but I could set a default of 30 days, guaranteeing that if someone doesn't set a duration, the secret or password is automatically going to expire. Now, there's something else interesting you can do with variables, and this is relatively new. I think it was introduced in Terraform 0.14, let's say, and that's validation of input. You might think that you'll always supply good input to your modules, but let's be honest, sometimes we make mistakes, and if somebody else is using that module, forget about it. Who knows what they're going to be passing in those variables? So you want to do some level of validation, so Terraform lets them know when they make a mistake. Now, one way to do that is by setting the type for the variable. In this case, I set a type of string, which means if someone tries to pass a map or a list into this variable, Terraform is going to throw an error. But in addition to that, I can now add a validation block that validates the input based off of a Boolean test. So the condition has to evaluate to true or false. And in this case, I am testing with a regular expression that the name of my service principal follows a pattern that I want. I want it to be at least 5 characters. I want it to start with a letter and not end with a hyphen. So the regex function checks to see if the input matches it, and then the can looks to see if the regex was successful. If it wasn't, then it evaluates to false, and Terraform throws up that error message. The error message needs to be a complete sentence, or you'll get a formatting error when you go to implement your module. Moving on to the last file, which is outputs. I needed 2 outputs here. One is the entire service principal object itself, and that's exactly what I'm given here. The other thing that I need is the password. And you'll note one of the arguments in the password output is setting sensitive to true. You always want to be sure that you're handling sensitive data appropriately. By setting the output to sensitive, that means that Terraform will not print it in any of the logs, and other resources will also treat it as sensitive. And it also won't print it to the terminal unless you explicitly set it as non-sensitive as an output. So setting a sensitive output is very important if that data is in fact sensitive. Now, once I have my module, I could in theory just save it to a directory and then every time I need it, copy that directory to my configuration. But that's not great, because if I decide to do that, now when I want to update that module, I'm going to have to update every configuration that uses it and update the source. And if I want to share it, now I have to send a folder or a zip file off to other folks. The better idea is to publish it to a registry, and there are multiple different places you can publish it. The most popular is the Terraform public registry. Anybody can publish modules and providers to the Terraform registry and have them publicly available to everyone. There's also a private version of the registry available on Terraform Cloud, and some other vendors have implemented the same registry protocol in their internal products. I believe GitLab has one. So there's multiple ways you can publish, but all of them pretty much have the same requirements. One of those requirements is that you put your module into source control. So here's an example of code that I've checked into GitHub for this module that I have developed. And you'll notice that it has a specific naming convention as well. Before we move on to that, I just want to point out that all the files we talked about are there, and a few additional files that I'll talk about in a minute. Now, the naming of your module does have to follow a particular pattern if you're going to add it to a registry, and that pattern is Terraform dash the name of the main provider you're using in your module dash the purpose of the module. In my case, it's Terraform Azure AD Service Principal. Now, you saw there were a few additional files in that GitHub repository, and 2 of those are very important. There's the README and the changelog. The README is the front page of your module when it gets published to the registry. It's what folks are going to see. So it should explain what the module is for and maybe provide an example of how it's going to be used. The changelog is also very important because as your module changes and grows, you're probably going to create new versions of it, and you want folks to be able to read through the changelog before they upgrade to see if the change is going to break anything in the way they're using the module today, or if they even want to upgrade. Are there new features that they care about? That goes in the changelog. And then lastly, there's going to be an examples directory, which has subdirectories that have common implementations of your module so that people can use it for a reference. If you want to see an amazingly well done module, I recommend checking out what is the most popular module on the public registry, which is the AWS VPC module. You can go on GitHub and check it out and see how a really well implemented module is done. Now, I want to talk about testing your modules because it's all well and good to write a module, but especially if other folks are going to be using it, you want to be able to test and validate your module does what you expect it to do. There are roughly I want to say a few different purposes behind testing. One is functional, just making sure that the module creates the resources you expect and that those resources are configured properly. That's just a basic functional test of your module. Then there's security testing, which is usually informed by your InfoSec team. They have some policies or best practices that need to be implemented, and you want to make sure your module adheres to them. Likewise, your compliance department might be weighing in on things, especially if you're dealing with sensitive data. There might be some encryption requirements or filtering requirements for firewall rules. Security and compliance tend to go a little bit hand in hand, but those are some of the test purposes you might have for testing your code. Now, there's broadly two types of tests you'll need for testing your code as well. One is static analysis, and that is literally just looking at the Terraform code in your module and running it against a tool that picks out whether or not you're following best practices. Terraform actually has a baked-in static analysis tool, Terraform Validate, which is part of the core Terraform binary. That command will at least make sure that your code is syntactically correct, but it's not going to check for anything having to do with security or compliance. There are other tools, stuff like Checkov, that will do that static analysis of code for you. The other kind of test is against live infrastructure. This is where you actually deploy the resources in your module and do functional or security or compliance testing against that created infrastructure to validate that it actually is what you want. Again, there's some different tools out there for that. One of the most popular ones is TerraTest, which is written in Golang. And what it actually does when you set it up appropriately is it will deploy the infrastructure for you. It will run whatever tests you define against that infrastructure. And when it's done, it'll tear the whole thing down. Now, ideally, you will implement these tests as an automated process in your CI/CD pipeline. And for instance, if you have this checked into GitHub, you can develop GitHub actions that fire off when new code is checked in and when a new version of your module is created. Speaking of versions, it's probably worth mentioning that if you're going to publish your module to a registry, you do have to publish it in proper semantic versioning. And that versioning follows the major, minor, and patch syntax, if you will. So, for instance, the major is going to be when you go from one major release to another, there's probably going to be some breaking changes or things that are permanently deprecated. A minor patch is there to add new features, but it's backwards compatible within the major family. And a patch version is going to be anything that fixes a bug or does something minor, but it's not a full-blown new feature. And once again, it should be backwards compatible to both the major and minor version that it is on. So make sure you're following that semantic versioning if you're not familiar with it. There's plenty of documents out there to help you. Lastly, for when you're updating your module and refactoring components of it, I want to point out some new functionality that's available, I think, in Terraform 1.1. Previously, when you published a new version of your module, if you moved an address around or something like that, it was incumbent on the module consumer to take care of that change by running Terraform state move. They no longer have to do that if you make use of the moved block, which allows you to set a from and a to address for any refactored resources within your module. All right, that is my presentation on developing your first module. Definitely check out my GitHub account. It's Ned1313 if you want to see the code that we reviewed during this presentation. If you want to reach out to me, you can check out my website. It's nedinthecloud.com, or you can find me on Twitter, Ned1313. Thank you so much for watching and enjoy the rest of Tech Skills.
All right, so I'm here with Ned Bellavance. Great job, Ned, on that presentation. That was awesome. Terraform's always awesome and fun. So we're going to do a 10-minute Q&A session here. And so feel free, if you're in the chat, to send us some questions, and we'll get started with it here.
All right, cool.
So the first question I have here, how important is an IT background to success with Terraform?
Okay, that's a pretty broad question. I think having some general knowledge of programming is going to be pretty important. You don't have to be like a full suite developer. You don't have to have gone to college for computer science to understand Terraform. But if you have some background in scripting, whether it's PowerShell or Bash or anything along those lines, that's going to help you a lot. And also just understanding how infrastructure is put together is going to help you as well, because usually the things that you're deploying with Terraform is infrastructure. So you have to understand how the things you're creating actually work.
Yeah, that makes perfect sense. So the next one is, if I wanted to build my first module, what is a good starting point?
Oh, okay. I mean, that could go in a lot of different directions. And I think a big part of that is going to be your background. What you typically deploy or what you are most interested in when it comes to infrastructure. So like, take me, for instance. I am very much in the world of virtual machines, or at least that was my background. I cut my teeth on VMware. So when I went to go create my first module, my thought was, I want to create a virtual machine using a module and maybe plug in some additional components. And creating something like a module for an Azure VM is perfect, because if you think about an Azure VM, it's not just the virtual machine. It also needs a network interface card. It might need a public IP address, and you may want to provision a network with it. Maybe you don't. So here's a chance to develop a module that has all of those components bundled together. And then it's kind of like choose your own adventure based off of the inputs for that module. So that's perfect for me. But if you're a database person, maybe what you want to do is create a module that stands up an RDS instance and also configures a bunch of backup stuff to protect that database, because that's the world you live in. Or, if you're a developer who loves containers and working on that, maybe you want to develop a module that helps you deploy EKS or use some other container service that's out there. So yeah, I would go with what interests you, because that will make it more concrete if it's a real use case, as opposed to just creating a module for the sake of creating one.
Awesome. Yeah, that's an excellent answer. We have a question here. What was the file naming requirements?
Okay. In terms of creating your first module, good question. So in terms of actually the files that go into the directory that compose your module, the only thing you need in there is a .tf file for your Terraform configuration. Terraform will put together all the .tf files that are in a directory and turn them into a single configuration. So you need those .tf files. Everything else is technically optional. Now, best practices say you should have a README in there that explains the purpose of the module and how to properly use it. And you might want to change log in there as you change and update and modify your module. And you want an examples directory of examples of how to use your module appropriately. All that stuff is optional, but it is best practices. If you want to publish that module up to a public registry, then typically it gets hooked in to some sort of source control. The one that the public registry HashiCorp maintains uses is GitHub. So you have to have a public GitHub repository with your module in it. And then to publish a version to the registry, you have to create a release with a version tag on it. And that's what signals to the public registry, there is a new version of this module available. So that's high level, all the things you need. It's actually very well documented on the Terraform website if you want to dig into how do I publish my module after I've written it.
Awesome. So we have another question. How to choose IAC tools like Terraform Pulumi? I don't know if I'm pronouncing that correctly.
You got it.
And Crossplane in the market.
Oh my goodness. Well, we're going to throw everything in the kitchen sink at this one. Okay. So I would say part of it starts with where you are in terms of silos and responsibilities in your organization, because all of these different tools are focused at a different end user. So Terraform, I feel, is very focused on the person who primarily deals with infrastructure. They're on the ops side. They're not a developer by trade, but they're interested in using infrastructure as code, and they want something that's a little more consumable than, say, CloudFormation or, well, CloudFormation's gotten better since they introduced YAML, but certainly better, than ARM templates, which are like miles of JSON. If you're coming from a pure development background, or you're very comfortable with a general purpose programming language like Python or Go or JavaScript, Pulumi is great because you can continue to use that programming language and it's really just a library or a set of libraries that snaps into that and lets you leverage the skills you already have. Crossplane is actually using Kubernetes custom resource definitions to deploy and manage your infrastructure, which is a whole other topic. So if you are like deep in the world of Kubernetes and that's how you want to manage and deploy your infrastructure, then maybe Crossplane is the solution for you. So I hate to say it depends, but it kind of depends.
Yeah, it's always a great answer though. Okay, and I have another question from Terry. Where is the best site to start out trying Terraform programming?
Ooh, yeah, lots of good options for that. If you just go to learn.hashicorp.com, they have tutorials, but that won't give you a sandbox to just play around in. So where do you get that sandbox, right? I think one of the easiest ways to get a sandbox to play around in is if you have an Azure subscription or you sign up for one, you can fire up the Azure Cloud Shell. And in that, it already has Terraform, the latest version of Terraform pre-installed, and it's already hooked into your subscription with your credentials. So you can just start hacking away on Terraform to learn it, and you don't have to have anything installed locally on your workstation. So that's a really easy way to just like get up and start it in a flash. And I think Google Cloud also, their integrated shell in the browser has the same components in it.
Oh, awesome. So I think we've got time for one more question.
Okay.
Let's see. How do I decide whether to build my own module versus getting one from the registry?
Oh, good question. So personally, my de facto is to go look for a module in the registry before I try to build one myself, because why do all that additional work if somebody's already done it for me and they're maintaining it? It probably makes a lot of sense, especially from an open source support perspective. If somebody's already written the module and it's a publicly available repository, if it doesn't do exactly what I want it to do, but it's like 90% of the way there, why don't I add it to their module and do a pull request as opposed to writing my own and maintaining my own? That's better for the community and better for the module. But if there is no module that does what you need it to do, then that's the time to write your own and, hey, maybe publish it to the public registry so other folks can benefit from your hard work, the elbow grease that you've put into writing a module. So that's my general advice is check the public registry first. And if there's nothing that's even close, write your own. But hopefully there's something that's like, it's most of the way there.
Yeah, definitely. It's kind of like the classic programming problem, that we run into. Should I use a library or make my own? It's the same deal. Well, thank you very much, Ned, for doing this Q&A and the great presentation.
Thank you.
This is awesome. And for everybody watching, we're going to go into a break and we'll be back at 3:50 and hope to see you all there.
All right. Thanks.
welcome back, developers. This has been a lot of fun, and I hope you're enjoying Tech Skills Day. I'm really enjoying all these presentations, all the chat that's going on in our chat room. It's been amazing. So up next, we have Paul DeCarlo. Now, he's a principal cloud advocate in data and AI at Microsoft, and the professor for the Bauer College of Business at the University of Houston. And today he's going to talk about simplifying developing and deploying intelligent video applications. This is going to be very exciting, and there is no live Q&A for this event. However, Paul will be in the YouTube chat to answer questions. So let's kick it off. This is simplifying developing and deploying video applications, intelligent video applications, and yeah, we'll kick it off.
Hello, and welcome attendees of Pluralsight Tech Skills Day 2022. My name is Paul DeCarlo, and I'm a Principal Cloud Advocate within the Data and AI Division within Developer Relations at Microsoft. Today we're going to be talking about simplifying developing and deploying intelligent video applications using technologies from NVIDIA and Microsoft Azure. Today's session is brought to you by Microsoft Learn, where you can find all sorts of hands-on developer content designed to teach you a variety of different skills and tasks ranging from all sorts of topics, from AI all the way to IT operations and anything in between. You can find all of the available content that we have at microsoft.com/learn. Today's session is based on a learning path titled NVIDIA DeepStream Development with Microsoft Azure. In this learning path, you can learn how to develop custom DeepStream applications backed by services in Microsoft Azure and securely deploy NVIDIA DeepStream-based workloads to NVIDIA-powered IoT Edge devices. This learning path is available for you to follow along at aka.ms/learndeepstream. We're going to be looking at a particular module within this learning path that you can see here, which consists of steps involved in configuring your DeepStream development environment, in addition to an introduction to the NVIDIA DeepStream Graph Composer. We're actually going to jump in here for the final module, the NVIDIA DeepStream Embedded Device Development with Microsoft Azure. Now, in this particular module, you're going to learn how to publish and deploy an ARM-based DeepStream container workload developed using the NVIDIA Graph Composer to NVIDIA embedded hardware running IoT Edge. This is going to allow us to run workloads on embedded devices that we develop using tooling provided by NVIDIA to make it very simple to seamlessly create intelligent video applications. In order to get started, you'll need to have access to the following prerequisites. These include an x86-based system running Ubuntu 18.04, an RTX-capable graphics card. These include the RTX 2080, RTX 3080, T4, or A100 NVIDIA graphics cards, an NVIDIA Jetson embedded device, for example, something like the Jetson Nano, the Jetson TX2, or the Jetson Xavier, that's equipped with at least Jetpack 4.5.1 GA. You'll also want to have some familiarity with container workloads in Docker, and it also won't hurt to have some familiarity with Azure IoT Edge and Azure IoT Hub. But don't worry, if you don't have those particular things down, we're going to cover those in today's session. We'd also like to suggest that you complete the previous modules. So the setup and configuration of the DeepStream development environment, in addition to the introduction to the NVIDIA DeepStream Graph Composer with Azure. Again, these modules are part of the learning path, NVIDIA DeepStream Development with Microsoft Azure, that's available at https://aka.ms/learndeepstream. So let's go ahead and get started by checking out the NVIDIA DeepStream Embedded Device Deployment with Azure module within our learning path. Let's go ahead and get started. And this will bring us to the introduction, where we can continue our story. Your boss is excited about the progress of your intelligent video application and is interested in putting your work into production. You learn that NVIDIA produces a line of embedded devices that are capable of running NVIDIA DeepStream Graph Composer workloads. You've decided to investigate using the Azure IoT Edge runtime to securely distribute your NVIDIA DeepStream Graph Composer workloads to these small form factor GPU-accelerated devices at locations around the world. This strategy will not only solve the issue of deployment, but also allow you to gather metrics from all devices in a single location. In this module, we're going to look at creating an end-to-end edge-to-cloud solution using components from Microsoft Azure and NVIDIA. Our first component is going to involve a cloud-hosted service known as the Azure IoT Hub. This will allow us to ingest high-throughput messages generated from our IoT device that will be equipped with Azure IoT Edge and allow for secure registration of the device in addition to being able to deploy workloads at scale to devices employed in the field. The workloads will be generated using NVIDIA's Graph Composer, which will create DeepStream-compatible intelligent video application pipelines using a visual editor. We'll follow along in Unit 3 of the learning path. As mentioned, Azure IoT Hub is a managed cloud service. It provides secure registration for IoT devices for high-throughput communication from device to cloud and from the cloud back to the device. You'll use this resource to register an NVIDIA embedded device and configure it with a DeepStream-based IoT Edge deployment. Now, you'll want to follow along with these instructions on your own to register an NVIDIA embedded device and configure it with an IoT Edge deployment. This will involve following the steps outlined here to create an IoT hub. What's important here is that NVIDIA DeepStream supports integration with Azure IoT Edge using an Azure MQTT protocol adapter library. This is something that extends the GStreamer NVMS broker plugin that is part of the DeepStream SDK. Using this protocol adapter, DeepStream applications can publish messages directly to an IoT hub in Azure by using the MQTT protocol. If you complete these steps, you'll be ready to continue with the rest of the steps that we'll be following in this module. The next thing we're going to do is hop onto our development machine, and this is where the DeepStream Graph Composer would be installed. And what we're going to do here is open up the graph that's contained within the DeepStream Test4 folder. You'll notice here that we have a pipeline that takes a single video source input, applies it to a muxer, applies inferencing using DSN for video, draws the results of that inference back to the video using the NVDS OSD or on-screen display, and then renders that output, but also pushes the output into something called the NVDS message conv broker. And as we mentioned here, what we're going to do is change this to utilize a new adapter that's going to allow us to very easily communicate with Azure IoT Edge. All we have to do this is change the property that's used in the NVDS message conv broker from using libnvds underscore kafka underscore proto.so to libnvds underscore azure underscore edge dot proto.so. So let's go ahead and do that. We'll select the NVDS message conv broker component, and then select down here under properties for message broker proto lib. We'll go ahead and make the necessary modification. And now that we've done that, we can go ahead and save our modified graph. And we're now ready to continue with our next exercise, building and publishing cross-platform DeepStream container images. In this module, we'll look at using the container builder to create cross-platform DeepStream container images that we can use to deploy to an NVIDIA embedded hardware device. This is going to leverage the DeepStream 6.0 container builder package, which will allow us to create a container that has all of the necessary dependencies needed to run our DeepStream workload. This is later going to be turned into an IoT Edge module that we're going to use in a deployment to actually run the workload on our device. We'll continue by following along with Unit 4 of the learning path. As mentioned, the DeepStream 6.0 Container Builder package allows us to build cross-platform container images. You'll need to use this capability in order to build a container that's compatible with the ARM64 CPU on your target embedded device. We're going to complete the following steps on our x86-based host machine that has the DeepStream 6.0 Graph Composer with Docker installed. I've opened up a SSH session to my dev box that will allow us to follow along with these steps. These steps assume that you've completed the steps described in the previous modules, which include the setup and configuration of the NVIDIA DeepStream development environment and the introduction to NVIDIA DeepStream Graph Composer with Azure. To begin, we're going to install the QEMU user static and bin FMT support packages. These will allow us to have the dependencies needed for cross-platform support in Docker. To perform this step, copy and run the following commands in the terminal on your host development machine. Once this installation is finished, we'll run the following commands to configure cross-platform support within Docker. Next, we're going to create a container builder configuration that will produce an ARM64-based container that will support the DeepStream test4 graph that we just saved in the previous module. To begin, we'll navigate to the following directory and open the DS test container builder jetson.yaml file with the following. Once we've opened the unmodified DS test container builder jetson.yaml file, we can scroll down all the way to the bottom where you should see the following. A section that mentions image name and has the following Docker container registry entry. Now, if you're not familiar with utilizing VI to edit files, we've created a simple section here within the notes that'll give you some quick tips on how to modify. What we're going to do is head over here to the image name section, and we're going to update this to look like the following. Once you've made this modification, you can go ahead and save the file by hitting Escape and WQ to write that newly changed file. We're now going to look at the parameters file that's utilized by this container builder file. We're going to change a few of the parameters within here. We'll go ahead and copy the following, and this will open the parameters.yaml file for the DeepStream test4. What we're going to do is scroll down here to the section that mentions message broker protolib and change this to utilize the Azure Edge proto shared object, just like we did earlier within the Graph Composer environment. We're also going to change the message-conv payload type that you'll see below to a type 1. Once you've modified the parameters.yaml file, it should look like the following. We'll go ahead and save this by hitting Escape, and then WQ to save the file. We're now ready to invoke the container builder, and this is going to perform the process of actually building our cross-platform container. We'll go ahead and copy this command, and we'll go ahead and execute it. If you haven't already built this image before, this could take a while to complete, so we'll give this a few moments to run and build the cross-platform ARM64 compatible Docker image. So don't be surprised if these steps take a little longer to complete on your machine. Again, if it is your first time running this command, it could take a while to pull down the base container images that are required for packaging this container. But once it is completed, what you want to look for here is that you get a message that looks like the following: successfully tagged DeepStream test for Jetson latest, which we see here in the output. I'm going to go ahead and clear this output from my screen, and then we'll go ahead and proceed with the additional steps. The next thing it's going to ask us to do is to publish our image into the container registry that we created in the previous module. I'm going to go ahead and copy this command, but we're going to have to make a quick modification here. Where it says login server, you'll want to use the name of the Azure Container Registry that you created in the second module of this learning path. So I'm going to go ahead and use nvgraphcomposer.azurecr.io, which denotes the login server of the Azure Container Registry that I used personally for those steps. So this will tag our image. And now we're going to run the next command, which will push our image into that Azure Container Registry. So I'll go ahead and modify again where it says login server to be nvgraphcomposer.azurecr.io. And this will begin the push into our Azure Container Registry. And with our cross-platform image now published to the Azure Container Registry, we'll now be ready to provision our NVIDIA embedded hardware for the IoT Edge runtime and be able to deploy this workload to our IoT Edge device as an Azure IoT Edge module. Now that we've pushed our container into our Azure Container Registry, we're ready to move on with the next module. In this section, we're going to look at how to configure the Azure IoT Edge runtime on NVIDIA Jetson embedded hardware. The Azure IoT Edge runtime is what turns our device into an IoT Edge device. This means we're going to have a securely registered device in our Azure IoT Hub that will be able to receive deployment specifications that define a series of workloads that will run on our device. Any of those containerized workloads can then be securely pulled down from an Azure Container Registry. And once they're running on the device, any telemetry or inference results that are produced, for example, by our NVIDIA DeepStream Graph Composer workload, can then be forwarded into the Azure IoT Hub, where they can then be consumed in a variety of different Azure services. For example, as input to a machine learning project, into various analysis services, visualization tools like Power BI, or Azure Storage for archival purposes. We're going to continue by following along with Unit 5 of the current learning module. It's interesting to note that this Azure IoT Edge runtime can be deployed on devices as small as a Raspberry Pi or as large as an industrial server. The key is that once a device is configured with the IoT Edge runtime, we can then securely deploy containerized workloads based on the deployment configuration specified in our IoT Hub. In order to complete the following steps, you'll need to have access to an NVIDIA Jetson embedded device. This could be a Jetson Nano, Jetson TX2, or Jetson Xavier, provisioned with Jetpack 4.5.1 GA or higher. We also assume that you've completed the steps described in the previous modules as part of this learning path. Those include the setup and configure an NVIDIA DeepStream development environment and the introduction to NVIDIA DeepStream Graph Composer with Azure modules. Now we're going to manually provision our NVIDIA Jetson device, and in order to do this, we'll need to provide it with a device connection string that will be created once we register a new IoT Edge device in our hub. And you can do that by following along with the official documentation here. It's important to note that as you're following through this documentation, you want to give your device a meaningful name. So I've chosen the name Jetson-Xavier-00 over here. And you'll notice that once it's registered, we're able to copy the primary connection string, which we'll then use in the next step. Once we've obtained that connection string, you can follow the steps in the documentation for installing the Azure IoT Edge runtime for Linux. You want to make sure that you follow the steps for using Ubuntu 18.04 here. And once you've gone ahead and completed those steps, you can go back to your device and verify that the Azure IoT Edge runtime has been installed successfully. So I'm going to go ahead and jump into my Azure IoT Edge equipped Jetson Xavier device, and we'll run the following commands. Sudo IoT Edge list will show us the currently running modules, and since this is a fresh instance, the only module that we should see running on the device is the Edge agent. Don't worry, we're going to modify this in the next step so that we can deploy our NVIDIA DeepStream Graph Composer workload as well. And it's also important to note that because that Graph Composer workload is going to be accessing the X11 environment, or drawing to the screen, if you will, that we'll need to give the container environment access to X11 resources. We can do this by running the following command, sudo xhost plus, and that will disable access control, allowing clients to connect to X11 from any host. And once we've gone ahead and completed those steps, we're then ready to proceed with the next part of the module. We're now ready to deploy our cross-platform DeepStream images to our NVIDIA Jetson embedded device using Azure IoT Edge. We'll accomplish this by utilizing the Azure IoT Hub to define a deployment specification which we will apply to our device that will then get picked up by the Azure IoT Edge runtime and deploy the workload specified within. We'll follow along by heading to Unit 6 of the current learning module, and we'll head over to our Azure portal. We can go ahead and select the IoT Edge option for our IoT Hub, which will show us all of our registered devices, and then we can click on that device to get details about that particular device. Once inside this screen, you can go ahead and select the Set Modules tab. The first thing that we'll do is provide the appropriate credentials for our Azure Container Registry. You can obtain these by going into your Azure Container Registry instance that was created earlier, selecting Access Keys, and there you can retrieve the username and password that will allow you access to pull containers from that container registry. Once you have these values provided, you're now ready to begin applying the addition of a new IoT Edge module. So you can click Add IoT Edge Module, which I've already done here, and I've named this DeepStream Test4 JSON. And we're going to give it a few different options as we're setting this up. We want to change the image URI here to be the Azure Container Registry login server. And then we're going to use the tag that we created earlier, that DeepStream _test4 Jetson :v1. We'll also need to provide some additional container create options. For example, we'll need to give this access to the GPU capabilities available on our device. And we're also going to bind the X11 socket so that we can draw to the X11 environment. Once you have these options set, you can go ahead and select Update. At this point, we're now ready to review that our module has been defined successfully. We'll click on Review and Create. We don't need to change anything in the routes, but just for completeness, our routes will by default have a from/messages/star into upstream, which means that any telemetry that's produced by our NVIDIA DeepStream Graph Composer workload will be sent to our Azure IoT Hub. If we click back over on the Review Create section, you'll be able to verify that you have the appropriate settings. And these can be looked at by looking at the example provided in the learning module. Once you've verified that the deployment configuration is correct, you can select Create to start the deployment process. That will set the module on our device, And from there, we can then go back to our Jetson device and run sudo IoT Edge list. From there, we should start to see that the new modules have been picked up, and it might take a while for them to download, but once they've been downloaded and configured, they'll start to run on the device. So back on our device, I'll go ahead and run sudo IoT Edge list. And you'll see we now have 3 modules, the DeepStream Test 4, the IoT Edge Agent, and the IoT Hub. I'm going to go ahead and restart the workload that we have specified for DeepStream Test 4. And that module has now restarted, and you can start to see that it is running, displaying in the X11 environment, and showing those inference results. One of the interesting things that you can note here is because we're now pushing those results, we can actually go back into our Azure IoT Hub and verify that data is in fact flowing into the hub. If we click back to our IoT Hub, you should be able to verify this in the overview section. We should now start to see messages coming from the device. You'll see that since I've started this workload, we're now starting to get inundated with a bunch of object detection results. And what we want to do with those results is really up to your imagination based on the solution you're trying to create. Similarly, if you like, you can also monitor the logs by running the following command to look at the logs coming from your device. These will flow very, very fast, but if you do hit Control-C to stop on them, you will notice that you can look at the actual composition of the message, and that should look like the following. So there's a lot of interesting details here. For example, we can see the object, the coordinates of the bounding box, what type it is. We can also see additional criteria, for example, whether it's a sedan, what the make is, the color, etc. And this all depends on how you've configured your actual inference detection in your DeepStream Graph Composer project. So depending on what you're trying to build, you can modify this and receive different telemetry based on your needs. Another thing we can do here is by heading back to IoT Edge section, we can click on our particular device, and you should be able to see that all of the modules are successfully running. Sometimes it can take a while for this to report appropriately, so go ahead and refresh here. While this is indicating an error, that is not correct, but you should see all 3 modules are in fact running successfully. So congratulations, if you've made it this far, you've successfully developed a production grade edge deployment of the DeepStream Graph Composer workload and deployed it to a real device by using Azure IoT Edge. Something to think about now. Using the strategies that we've described in this module, how might you modify an existing DeepStream reference graph to support a wildlife conservation solution that counts unique instances of endangered species by using live camera feeds? Which components would you need to modify to support this solution? Would you need to make any modifications to the overall deployment strategy? Thinking about this out loud, we could simply change the object detection model that we're using to, instead of detecting vehicles, people, and bicycles, we could use something that detects the endangered species that we're interested in. We could also, instead of connecting to a local MP4 file, use the RTSP streaming capabilities to be able to connect to a live feed. This would really only require us to modify the inference step as well as the video URI source within our DeepStream Graph Composer. And from there, we wouldn't need to make really any modifications to our overall deployment strategy aside from specifying the new container that we could then pull from our Azure Container Registry and deploy it down to our device. We're now ready to continue with the knowledge check. In summary, in this module, you learned how to modify a DeepStream Graph Composer application to publish data to a hub in Azure IoT Hub, build and publish cross-platform DeepStream container images, and then push those to a container registry in Azure, configure the Azure IoT Edge runtime to run on NVIDIA Jetson embedded hardware, and then deploy those cross-platform DeepStream images to an NVIDIA embedded device by using Azure IoT Edge. We'd like to remind you that today's content was brought to you by Microsoft Learn. If you're interested in more interactive tutorials such as this one, head over to microsoft.com/learn, where you can find tons of interactive content for a variety of different subjects related to the latest trends and technology. And as our final call to action, we would like to suggest that you go ahead and take the full NVIDIA DeepStream development with Microsoft Azure learning path for a spin. You'll be able to learn everything about how to develop custom DeepStream applications backed by services in Microsoft Azure and securely deploy NVIDIA DeepStream-based AI workloads to NVIDIA-powered IoT Edge devices. The learning path is available for you to complete at your leisure at aka.ms/learndeepstream. We hope you've enjoyed today's presentation and look forward to your continued learning and success on Microsoft Learn. Cheers.
Welcome back, developers. That was another great presentation by Paul. Now, thank you all for watching and taking part in our chat. This has been a blast. So our next presentation is going to be a talk by Romeo Radanyi. Now, Romeo is a certified architect and a leader in the cloud domain with years of experience in AI and ML. And he's now on a journey to learn more about quantum computing. So he's currently the vice president at Moody's, leading their solutions architecture function. And today we've got a really great talk coming up here. It's going to be about getting started with quantum computing with no PhD needed. It's very exciting. Let's check it out.
Hi everyone. My name is Romeo Radanyi, and today I will talk about quantum computing. You might ask, why should I care and listen to this session? Isn't this some super complex subject that will have zero impact on my life or work, and only scientists and students whose life might be made a misery because of it should care about? Well, if you are in the field of computer science, but elsewhere too, quantum computing will have an impact on you either directly or indirectly, and most likely during our lifetime, and maybe even revolutionize a few things on the way. There is certainly a ton of hype about it, so want to be careful not to oversell it, as there are no practical applications as of today. But, based on sources like IBM, Microsoft, Google, and more, there are a ton of potentials and real promises in harnessing the weird nature of quantum physics through quantum computing, like in the field of chemistry, genomic analysis, drug discovery, logistics and supply chain optimizations, or finance in general, through things like portfolio optimization, better derivative pricing, credit scoring. It will also benefit artificial intelligence and machine learning algorithms and their training, and will also shake up the whole cryptography sector for sure. All of this is also being reinforced by the ever-increasing venture capitalist funds and investments into quantum computing related startups and companies, both in the hardware and software space. Governments are also continuously pumping money into it, mainly because of its impact on cryptography and encrypted communications. As you might have heard, quantum computers can break RSA, but I will explain that later. If you are like me and missed out on the birth of the internet or classical computers simply because of your age, it might be one of those areas where it would be just the perfect time to get into, or at least to know about and keep track of its advancements and be prepared, just like how it was with cloud almost a decade ago, or with AI 5 or so years ago. But how is it different from the times when classical computers were invented? Well, we have the internet and cloud computing to control even the most complex cutting-edge hardware from anywhere, which is a unique time to live in for sure. So what is quantum computing? Well, when I heard about it the first time, and I'm sure others can relate too, I visualized something like this. A lot of quantum mechanics and physics, or symbols, I have no idea about what they mean, or maybe even knew what some of them meant once at uni, but purposely trying to avoid them since. And to some extent, it was actually like this, just 10 or so years ago. It was only for physicists, folks with PhD. But as the industry moves forward in a similar way to what happened with AI, for example, it's becoming a more normal thing, and people like me, who has no PhDs in physics, can still understand it and leverage it. So quantum computing fundamentally is a new paradigm, where we try to harness the law of quantum physics via quantum computers to tackle problems that are very difficult or impossible for classical computers to address today. We can do this by encoding information into quantum bits or qubits, which can be something like a superconducting loop of wire, or an ion or an atom held in a laser trap, or an electron combined with a quantum dot, just to name a few examples. And on this slide, you can actually see a quote-unquote typical quantum computer using superconducting loop of wires. And actually, in general, if you do Google quantum computers, you will definitely find something like this. But it is, in essence, a massive fridge. Huge, expensive, complex, supercharged fridge that takes the chips with its cold heart to millikelvin, close to absolute zero, which basically helps the chips to take on quantum properties. It is actually often called a golden chandelier as well. The actual qubits and where the computations are happening is on the right hand side, which is the actual quantum computer itself. This big thing, and obviously I'm just oversimplifying here, just there to put the superconductors to absolute zero temperature and help interfacing the qubits with the upper parts, and sometimes even with classical computers to manage its control, interface and API. And as I mentioned, there are many different ways to physically build and engineer quantum computers. So there's a lot of complex capabilities and research involved in this. But as I alluded to earlier, what is crucial to know is that we have cloud computing and internet. So you can actually control this whole stack over the web, design algorithms for it, circuits for it, send it over various APIs and get results out. You can even use basic Python to control these fridges, which is pretty impressive if you ask me. And some other very familiar tools too, which I will talk about later. What is also very interesting on this slide is the fact that you can even see the qubits on that chip. It was a while ago we could see actual bits for classical computers. And fun enough, this one is a 7-qubit IBM chip if anyone is interested. I only pointed out 5, but I'm sure you can find other 2. The purpose of the quantum computers then is to get these quantum bits to interact with each other in a controllable way, so they solve sort of useful computations. Oh, and by the way, I will explain what a qubit is in a minute too, so don't worry if still this doesn't make any sense. But now you at least know how a quantum computer looks like and works on a high level. Given we also know that quantum computers are nothing like a normal desktop machine or silicon-based one that relies on transistors, what could have been the motivation behind building something so complex as a quantum computer? Well, there is a ton of talk about how the Moore's law is coming to an end. Even the former CEO of Intel said this. And in case you haven't heard of Moore's law, it says we will double the number of transistors on integrated circuits every 2 years, which basically translates to doubling computing power every 2 years. And although we are not struggling just yet, and the feature size is still dropping, it is definitely getting harder and less affordable to fit more transistors onto a single chip. Hence, we are relying more on parallelism and more chips. It basically poses a physical limit to what we can do and how far we can actually go. So also, instead of making faster chips, the industry diversified. Whatever application or appliance you look at, you got a custom chip for it. You want a mobile phone, a toaster, a drone that flies on Mars, you got a chip for it. So something is definitely happening to classical computing that makes it right to put different kind of computing into the mix, like quantum computing. But there are also other crucial factors. So let's look at the actual differences between quantum computing and classical computing. We know with classical computing we calculate with transistors and gates, which can represent either 0 or 1. And we know that the computational power increases in relationship to the number of transistors we have on the chip. Now with quantum computing, you have something called a qubit, which can represent 0, 1, and any of those two at the same time in those tiny superconducting circuits in the chip, if kept close to absolute zero temperature, as it can maintain its quantum properties only in that state. If you add more qubits and get them to interact in a controllable way, you can increase the compute power exponentially. But qubits are very difficult to control and have high error rates given all the complexity involved in maintaining their quantum properties, while also having connections and circuits back into the real world. Quantum computers are noisy today. We are in the so-called NISQ era, noisy intermediate scale quantum computers, which is like being in the 60s for classical computers. And everyone is racing to search for and engineer less noisy qubits, and obviously find error correction solutions that works and complements those qubits. Now, obviously, with classical computers, we don't have any of those challenges. we had decades to improve them, so can work on normal temperature with no or very little errors. I mean, we carry a classical computer with ourselves every single day, and we cannot even live without it. It would be quite difficult with a quantum computer just yet, to carry a fancy fridge around. Now, given the properties of a qubit and how they can interact, quantum computers are great at optimization and simulation tasks, while classical computers will remain focused on everyday tasks. So quantum computers will not replace classical computers, but rather collaborate with them. So don't worry, you won't need any of these to play your favorite games. So we know qubits operates according to the law of quantum physics, where physics work differently on a particle and subatomic level. But the most common way to demonstrate quantum mechanics is by shining a light through a barrier of two slits. Some light goes through the bottom slit and some goes through the top slit, and the light wave knock into each other to create an interference pattern. Something like this. It shows the light's wave-like features perfectly. Now, what is also interesting to note is that when the light from one slit met up peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot, shown with the green line. But if the troughs with the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. Hence it is called destructive interference, shown with the red lines. Basically light cancelling itself out. You can actually reproduce this with two balls next to each other in a lake, or with dropping identical stones into a still pool of water and making them to produce small ripples. Now if you change the flashlight to fire individual photons one by one, which are the elementary particles that comprise light, you would assume as each photon travels through a single slit, they would have nothing to interfere with, but still, you end up with the same interference pattern. Now, according to quantum physics, until you don't observe or detect these photons on the wall, each photon exists in a superposition state, as if they would be traveling all possible paths at once. That remains until the superposition collapses upon measurement or observation into a single point on the screen or wall. Qubits use this ability to do very efficient calculations. Imagine a maze where you could contain all the possible routes in this superposition state and then collapse the state of the superposition to find the right way out. For a classical computer, you would literally need to evaluate each route individually. So as you know already, to create a stronger quantum computer, you cannot just add more qubits. Now, there is a quantum mechanical property called entanglement, which lets scientists to push multiple qubits into the same state, even if they are not in contact with each other. And although individual qubits exist in a superposition of two states, this can increase exponentially as you entangle more qubits with each other. Two qubit systems can store 4 possible values. A 20 qubit system could store more than 1 million. But what does this actually mean in terms of computing power? Well, let's look at the basics of cryptography and start with prime numbers. You know, a prime number is something that can only be divided by 1 and itself. And although it is super simple for a calculator, and actually for some humans to even multiply prime numbers, it is actually much harder to go to the reverse direction, since when you multiply two numbers together, the result number is a number that can only be broken down into those primes, n itself, and 1. And this is actually how RSA works. You can only decrypt RSA security by factoring the product of two prime numbers. Each prime factor is typically hundreds of digits long, which serves as a unique key to a problem that is effectively unsolvable without knowing the answer in advance. Like this one. So do you want to know the answer and a little fun fact? Well, here it is. And just for reference, the factorization of RSA 250 utilized approximately 2,700 CPU core years using a 2.1 GHz Intel Xeon CPU. And 1 core year equals to running 1 CPU core continuously for a full year. RSA 260 has 260 decimal digits, which is 862 bits, and has not been factored so far. But it is still important to note that Peter Shor, an MIT mathematician, made a novel algorithm for factoring prime numbers, whatever the size. So basically, one day, a quantum computer could just use Shor's algorithm and its computational power to hack anything and everything that uses RSA-based public key crypto system, which is most of our communication channels, emails, VPN, and so on. So obviously, this is constantly being sought of, hence all the investments into quantum technologies in the first place by governments, and to be prepared. But this is also why you might have heard of the term capture or harvest now and decrypt later, as they could steal encrypted information now, and although they cannot do much with it still, once quantum computers are mature enough, they could use them to decrypt it. For example, OpenSSH recently made a change and release as well on the 8th of April to improve their security and be prepared ahead of the more advanced quantum computers, and to protect against exactly this capture now decrypt later attack type. But how hackers could get their hands on quantum computers? Well, funny you ask, as this brings us back to cloud computing. Cloud providers like AWS and Azure and Google are spending hundreds of millions to partner with quantum hardware providers like Rigetti, IonQ, and so on to provide you an obfuscated quantum hardware via their standard APIs or Azure, Google, and AWS console. As you can imagine, every single cloud provider is working tirelessly to not be left behind in the quantum race. Amazon Web Services released the service called Bracket in 2020, for example, to enable AWS users with quantum computers and hardware through various partnerships. Microsoft is also doing the same with an even wider range of partners and even with their own research around topological qubits, where they actually recently made some massive breakthroughs and potentially validating a theory that could help them to create a new kind of qubit and help to solve humanity's greatest challenges. And this is one of the many reasons why quantum computers are exciting, because they can be accessible and will be even more accessible when we will start talking more about quantum advantage, or the so-called time when quantum computers definitely outperform classical computers in various complex tasks. But aside of them being available via the cloud, there are also a ton of resources to get started with quantum computer and rely on tools that many of you might be familiar with, such as everyone's favorite Jupyter Notebooks and Python. There are also open source frameworks, such as Google's Cert or IBM's Qiskit. But if you want to play with drag and drop and no code first, you could even head over to IBM's website to play with the Quantum Circuit Composer in your web browser and simulate a bunch of qubits and quantum computer-based operations. Well, we'll need a bit more than this session to understand how those work though, so bear that in mind. And if you wish to try quantum circuit simulation on GPUs, you could try the recently released Q Quantum Container and SDK. To really understand quantum computers, it is inevitable as of today to use classical computers for simulating quantum circuits, and how errors affect their performance to be ready for the next step in the information age. So as you can see, the space is growing, but that brings me to my closing remarks. As I wanted to remind everyone, there are no practical applications of quantum computers as of today, so don't get fooled by the media. But the potential is there. It opens borders that were closed until now due to computational limits. It also creates new way of thinking about algorithms, solutions, platforms, and communications and security. It is indeed the next step in the information age. And according to the father of quantum physics, nature is quantum, and I'll let you Google the full quote. But it also provides a way to model and simulate real-world scenarios that until now have been merely simplified, which is super exciting. As an outsider still, it really does look like a space race. All the countries, literally every single one of them, is making a statement regarding quantum. There is a transformation going on, which could be quite exciting to be part of if you ask me, even before quantum advantage is reached. And then lastly, it is definitely a topic that needs more time than 20 minutes to learn. So please spend some time googling around and even look into all the claims I made in this video as well. Well, and look into all the things we haven't discussed as well, which is a lot. And with that, I hope you enjoyed this session and got a little bit of an appetite for quantum computing, as I certainly enjoyed the ride so far. Thank you for listening, and now let's get to the questions.
I'm here with Romeo Radanyi. Great presentation. I really like that. Good job. And I have personally a bunch of questions, but I know that we don't have the time for that. However, we do have a set of questions here that we'd like to ask you, if that's all right.
Yeah, no, sounds great. No, thank you. Thanks, Jeremy.
All right. So the first one is, from an environmental standpoint, does quantum computing take up more electricity to run? And if so, how much more?
Right. So this was actually something that I did look into a fair bit as well, just even before I started like thinking about quantum in general as well. Like, it's actually claiming to be a key to the future from this perspective too, because it's actually the contrary. Quantum computers going to use significantly less energy, which could even lead to like, lower costs and decreased fossil fuel dependency as adoption grows. And, as I actually mentioned in the presentation, because quantum computers needs to be kept like at low temperature, like 50 millikelvin, it leads to, which is like actually colder than the interstellar space, it's needed for the processor to superconduct, to basically like, conduct electricity with like no resistance. But as a result, these processors like use almost no energy and generates like almost no heat. So the power draw of like a quantum computer, or the amount of energy it consumes, is literally just like the fraction of like a classical computers. So to actually compare it to something, like most modern classical supercomputers use in between like 1 to like 10 megawatts of power on average, which is basically enough to like meet the demand of like 10,000 homes, and which is like, I think like the price of 1 megawatt is like $1 million in the US for a year, which could even be an outdated figure with the current prices. While a quantum computer, like Google's D-Wave computer, is using like 25 kilowatts of power to cost, and which costs around like 25K per year. And most of that power actually goes into just cooling the processor. So yeah, it's gonna be pretty efficient.
Oh yeah, that's great news, because yeah, it's a heat generation. I didn't think about that angle of it. The heat that comes off the classical computers is where most of that power is expended. So yeah, that's pretty interesting. What is the number one obstacle for the folks that are developing quantum computers today?
Well, I mean, there are like several challenges building like large-scale quantum computers, but I think probably the most pressing one is like keeping the qubits like actually stable, as the power of it comes from the ability to store like, complex states in a single qubit. And as I pointed out, we are in this NISQ era. So we have like noisy qubits with a ton of errors, as it's really difficult to isolate them from any kind of external factors, and also keeping them stable, which means there will be probably many iterations of like quantum computers and hardwares and, error correction methodologies, but before we can like comfortably and reliably able to do like large scale computations on a ton of qubits. But at the same time, I don't think it means that we could not simulate certain scenarios, or could not even work with even the noisy ones, and just be prepared for the time when we don't have to deal with this much error or flakiness.
Okay, awesome. And the next question is, what are some areas of study that learners can start studying now to prepare for quantum computing in the future?
Well, I have to say I'm one of those learners myself. So I would suggest to even start just understanding the basics first, without like math involved. Like just the concepts, like the ones I was talking about today, using different explanations, like what is superposition, how it works, how it is being supported by quantum computing, and just try to dig into every single concept you hear in these sessions, like what is decoherence, what is entanglement, what is annealing, and so on. And best to start with those concepts, as those haven't changed since quantum mechanics and quantum computing emerged. But frameworks, services, and even the hardware and the software will probably change and differ in the next few years. And frankly, with that approach, like sooner or later, the concepts will just make sense and make up a cohesive understanding of how quantum computing works. Obviously, there are tremendous amount of resources online to get started. I mean, Pluralsight has a course on it. The big three cloud providers like Microsoft, AWS, Google have webinars and videos on it. And probably all the future conferences will include an increasing number of quantum sessions. And if you want something deeper or more in-depth, like MIT and other top universities got a ton of great publicly available lectures and courses for free on YouTube even. So yeah, ton of resources to get started with. But I would just say, just start with listening to different takes, even on the same concepts I have talked about today. That should get everyone started. Oh, and learn Python. It will be a must for quantum computing because it's actually somewhat similar to like AI/ML. So although at least there was an option to choose R, if you are not a fan of Python, here it's actually pretty much just Python from what I have seen. But it is a fun journey though, so don't get surprised if you end up getting carried away pretty quickly and just want to know more. It's a great feeling learning about something that will most likely change our lives and pushing the boundaries our collective knowledge as humans.
Yeah, definitely. Awesome. You briefly mentioned quantum advantage in your talk. Isn't that the same as quantum supremacy that Google claimed to achieve a while ago?
Yeah, so quantum advantage actually refers to the moment when quantum computers can compute hundreds or 1,000 times faster than a classical computer and solve actual useful problems, while quantum supremacy is achieved once quantum computers are powerful enough to complete any calculations that classical supercomputers cannot perform at all. So even useless problems, which are complex for classical computers, like certain random sampling tasks. And what's actually quite funny is that Google claimed they built a quantum computer that carried out calculations exponentially faster than computers built around classical bits. But on the other hand, researchers at IBM, who are the main rivals of Google in the race of commercializing quantum computing, preempted them with a claim that Google had exaggerated its quantum computer's advantages and that quantum supremacy wasn't a meaningful achievement anyway. So frankly, not quite sure whether quantum supremacy really matters anymore, and the industry seems to avoid the term nowadays anyway, but IBM even wrote a press release about it. So I definitely recommend anyone who is interested in this subject to just check it out and read up on it.
Yeah, definitely. Okay, so our final question is, if you were to pick one industry that will be impacted the most before the others, which one would you pick and why? It's kind of a tough one. I mean, I think every industry will be impacted at some point, so that one is kind of a tricky one.
Yeah, it is an interesting one. But I guess maybe if I just go back to my thought process on even how I made the presentation itself, I do think that I think my thoughts really align with that. I genuinely feel the biggest impact will be on cryptography and security in general. I mean, Shor's algorithm is the real killer here, right? Every single company probably needs to sooner or later invest into becoming quantum resistant or just ready for post-quantum cryptography and move on to quantum safe algorithms. So for example, NIST, the National Institute of Standards and Technology, anticipates publishing quantum safe algorithms later this year. And it's a real concern for the Department of Defense, but it's also true outside of the US as well. So honestly, if I would pick one, it would be probably cryptography and defense, because it's could also sound pretty scary.
Yeah, definitely. I have a feeling, so we heard it here first about quantum safe stuff. I have a feeling we're going to be hearing that term a lot in the future. Yeah, for sure. Well, thank you very much for answering the questions, and thanks for the great presentation. That was awesome.
No, I appreciate it. Thanks for having me. Thank you.
Hello, developers. Developers. I don't know if you remember that talk, but throw that in. That was a great talk by Romeo, and definitely one that's way outside my wheelhouse. So I was really interested in that. That was a lot of fun. So thank you all for attending Tech Skills Day 2022. This has been another really fun Tech Skills Day. I've learned a lot, and I hope you have as well. And I'm so glad that everyone hung out with us today, participated in the chat. This has been a lot of fun. So we would love to get to know you more. So please jump over to our Discord and you'll get a chance to chat with me, the other hosts, the attendees, and I will look forward to seeing you all there. Thank you again.